GMT Dr. Sarthak Singhal is here, one of the coordinators in this, and mathematics is Dr. Nitin. Mathematics side is also here.
Yeah. So, events Department of Physics, Mathematics and ECC है और इसमें हम
जनियानी जी शायद ऑनलाइन ज्वाइन करते हैं.
हाँ. So just make sure saying that are they able to hear us? You speak to any one of the right now. Otherwise, in between you will be.
Hello, are we audible? Hello.
Yes, I'm Vijay Janyani. I can hear you.
Okay.
Good morning, sir.
Yeah, good morning. Good morning.
So I can hear you, and I hope you can all hear me.
Yes, sir, we can hear. Thank you.
Yeah.
So, Anis. So okay, we will start into Anis, make sure that when the sir and all are speaking. A very good afternoon to all of you. Can you hear me? Okay. A very good afternoon to all of you. I, Kavita Lalwani, faculty in the Department of Physics, MNIT Jaipur, feels privileged to welcome you all on the behalf of organizing committee in the inaugural ceremony of an online short-term course on software tools and techniques for scientific publications, which are Root, GNU Blog, GeoGebra, along with the state-of-art techniques at MNIT Jaipur. I extend my welcome to our chief guest, Professor Uday Kumar R. Yaragatti, Director, MNIT Jaipur, and the guest of honors, Professor I.K. Rana, faculty from Department of Mathematics, IIT Bombay, and from Professor Anki Roy, faculty from IIT Indore, with us connected online. I welcome to all faculty members, students, participants from the multidisciplinary fields from the various institutions around the country who are connected today with us in the online mode. This program is organized by the Department of Physics, Mathematics and ECE at MNIT Jaipur and is sponsored by the TCube cell of MNIT Jaipur. This program will run for 5 days, starting from today to till September 8, 2020. So you will all enjoy the hands-on training and the learning on the state-of-art techniques on the data analysis during the weekends as well. Our goal to organize this STC is to provide the hands-on training on the software tools which are Root, GNUplot, GeoGebra, along with the state-of-art data analysis techniques. All these software are the open sources and easy to install, set up locally in the laptop, desktop, or the workstation or server, where you have a various operating systems such as Windows, Linux platform like Ubuntu, Macs, etc. These scientific tools and techniques are very useful for the data analysis, plotting distributions in terms of graph, histogramming, which can be a one-dimensional distribution, two-dimensional and three-dimensional distributions coming from the theory or any calculations or from any experiment in the science and engineering field. Further, the hands-on training on how to write the paper, report, dissertation, thesis, and journals using most famous editor, which are the LaTeX, also will be provided during the workshop. So I must say it is a complete package on analyzing the data, visualizing these results in terms of histograms and graph, and compiling them in the presentable form and publish these results in the conference or in journal, which students and faculty as a participant want to publish. Further, these software tools and techniques are widely used in multidisciplinary fields of science and engineering, such as medical physics, nuclear physics, accelerator physics, space physics, and device physics, along with the material science applications. Therefore, we have a wide range of the participants who have joined in this short-term course. They are mostly UG, PG, and PhD students and faculty from the various fields, such as mechanical engineering, civil engineering, ECE, maths, computer science, physics, and IT. Further, to train the students and faculty of this STC, we have designed our sessions in two phases. In the first phase, we will introduce the software through invited talks and their applications by eminent experts who are connected online with us, Professor I.K. Rana, faculty from the Department of Mathematics, IIT Bombay, and Professor Anki Roy from the Department of Physics, IIT Indore. Welcome you, sir and ma'am. In the second phase of this workshop, we will provide the hands-on training on the software tools and techniques. In addition, we have also planned a dedicated session especially to discuss how the students and faculty can use these software in their own projects or fields in which they are working, or they can design for the new projects in their career. I wish that all the participants will learn and gain a very good knowledge from this hands-on training on the software tools and state-of-art techniques in the data analysis, and come up with the new projects and idea to be implemented using these software in interdisciplinary fields. Now, I would like to invite and welcome our director, Professor Uday Kumar Aragatti, who is the chief guest of this event, for the opening and welcoming remarks on this wonderful event and motivate the online participant. Now, sir, you just address the online audience.
Yeah, good afternoon, all the beautiful people here. Respected Professor Rana from IIT Bombay, Professor Anki Roy from IIT Indore, my colleagues, Professor Vijay Janani, Professor Rohit Bakar, Dr. Rahul Singhal, Dr. Sanjay Butcher has just taken charge as head of the Department of Mathematics, coordinator Dr. Kavita, and co-coordinators KV Kama, Anis, Sarthak, and Ritu Agarwal, and all the participants from all the departments, especially from maths, physics, and ENC. That's what I was wondering. Maths and physics department have taken a lead to show you how to draw the graph and other things, whereas the engineers would have been heard about drawing GNU graph or other graphs, but may not have tried it. I'm talking about the UG students, and PG would have done already, and PhD, of course, this is your right to do it also, otherwise you cannot publish any papers. I think even there is a mention of latex also. How many of you know latex that you only know? I think Bombay, IIT Bombay and IIT, most of the IITs, that is a requirement when they enter into the research field. I'm take a master degrees or PhD. Latex is not very popular with other UG students, but once you work onto that, it becomes very neat and tidy and handy. Otherwise, it's very difficult because it's looks like something like a coding. Then, yeah, that's what the mention about these softwares is very much required during your paper publications, of course, as well as your research work also, to get the precisely know what you are doing, which can be compared with the experimental results if you are doing experiment. Otherwise, if your higher authority is satisfied with the software, well and good. So the software should be self-explanatory what you are doing. That is more important. So instead of you asking your friends or juniors or even students are very smart in this. You have to learn it. Now it's a time for you. And it has to be virtual. Everything is going on virtual now, what we call it digitally or online programming. If you are not well aware of all these things, it's a handicap for you. You will not be called as a good teacher also. You know it, you might have been experiencing for the last few months or few weeks or few days when you are taking online classes. Nobody is hearing you. You can just see your face on the screen and talk. I can't even see your expressions, whether you are understanding or not. So, but if you put a beautiful graph, what it tells about what the characteristics of what you are talking, that will be self-explanatory and the students can understand very well. And you also can understand very well. For that, you have to learn these tools. You might have been doing it with some process earlier or physical process also. Now it is time has changed. I'm repeating again and again. You have to work with that. I think I have almost, how many participants are there? 40 plus participants are there. Few may be joining because it's a 5-day program. Take advantage of that. That's important. My MNIT is doing a lot of such training courses under the head of TECUP 3 and helping the needy people. So you have to take the advantage of that rather than just hearing some high-end speakers, orators talking about how to do the online classes or national education policy or whatnot. Okay, now there may be discussion on a GDP crash. But see that GDP is crashed, but the shares are not crashed. That is the crux of your thinking level. When the GDP crashes, even the shares should fall down, no? BSc, NSC should come down. They are not come down. So what is that? Because everything is, you are seeing through the graph only. If you understand what GDP is and what shares are. Okay, anyway, I am not into shares. I know what GDP is. It simply shows the graph. What is that graph? To understand what the graph is, you should know what you are doing with that graph, how you are doing with that graph. Because GNU plot, I think I studied some 30 years back only, physically we were doing, on a graph sheet. Now we have a software for that. So it will be more easier, but very difficult to understand the basic theory. When you are doing the research or experiments also, nowadays you are all very intelligent and very smart in getting these graphs done very well. But you should understand physically what the graphs mean. What's happening to the coronavirus or COVID-19 graph? Is it flattening or what? So we don't know. People talk about flattening, peak, exponentially rising. I think there is a news this week. It will be at the peak level. I don't know. It may be fake news also. Okay, whatever it is, there's something there. COVID is there. It's creating havoc. Or the media people are creating havoc on that. So you should get immune to yourself, Similarly, you should get immune to all these softwares. Otherwise, you are a outdated person. Then you should keep on depending on somebody else to help you out. Instead of that, this is a time you don't have to go out anywhere. You are not coming to the institutes. Looks like everybody is work from home. कितना क्या काम करते रहोगे? Somewhere you give some time to study for yourself rather than teach for others. So now this is the opportunity where my MNIT is giving you with the help of physics department, E&C department, and maths department. And because see, the maths people know the graph in their way. They have a full specialization called graph theory. Physics people are the researchers, virtually, and E&C people. Okay, all these are branches to name, to specify themselves. They are to have more HODs and more conveners. It's a branching, but everything is just learning science. It's just a learning of science to make our life easy, simple, in a calculated manner. And people think that they are creating novel ideas and indigenous ideas. I doubt. Because everything is there already thousands of years back only. It's been, maths has been done. Everything is precisely created. Indians were the first people to say that Earth rotates around the sun. And exactly how many days? 365 or 265? 365.25. See, that 0.25 is not your calculator or your computer has calculated. It's been done thousands of years back only. How did they do that? When they didn't have the scale also to measure. A lot of such things are coming out. Because nowadays, okay, the WhatsApp is a nuisance, but in some cases you get a very good news, from different parts of the world. That Indians have done this, Indians have done the ancient Indians, it is their ancient mathematics is like this way. Everything is calculated. Even Ashok Chakra, there are 24 spokes, no? See, what is the angle between each spoke, two spokes? How it was calculated long back. Ashoka Chakra, okay, that has been put into our flag later. It was during King Ashoka only it's been done. How exactly that cutting is been done? You cut the circle into 4 parts, 8 parts, 16 parts, you won't get that. That's a calculation, The pi, the decimal, the distance between the moon and sun, the distance between sun and the earth. What is the ratio of distance between sun and the earth and the diameter of the earth? Or distance between moon and earth divided by the diameter of the earth? It's 108, which was calculated long back. To make the people know that you chant 108 times of whichever God you want to have. Om Namah Shivaya, Jai Shri Krishna, Sri Ram, Jai Shri Ram, Hanuman. Even you can use Jesus or Allah also, tell 108 times. There may be some power in that. What is that power? That's been calculated, The maths people, the physics people have calculated the frequency of sound, the frequency of variations, which now we call it as a electronics and communication branch. Everything is scientific in this world, which is been shown to the world by Indians hundreds, thousands of years back. I'm not getting, yesterday only I found out some very interesting formula and interesting thing which says that everything depends on the science. There is nothing spirituality. There is nothing jadutona. Okay. There are few people, okay, you might have been seeing now, what is that movie, Shakuntala Devi's movie, how she calculates and all. Okay, different type of power. There are a lot of such people which has not come to the lime time. So all these things which were on papers or on stone carvings and all has been converted into software. And that is what, unless you know, see, it's very simple to say, okay, I can do it from software, but how you do it, that's more important. Suddenly, your friend or your helping people are not near you. You have to send the result. That's what it's Dr. Kavita was telling. All your publications and all, most of the publications, they can't see the physical system. They'll see only the graph in the conclusion part, what you give, and that fetches you the credentials for publication or not. For that, you should know what you're doing, no? She kept on talking about plagiarism and all. So if you do the plagiarism, you will not understand what you are doing. So the reviewers may ask you the questions, okay, how did you do this? How did you do that? Then you have to take the help of your friend who is with you and he might have gone abroad. Okay, now you have tools you can connect online or video call or face time call, but still you are not sure. So to be sure, you should know at least the basic principle of all these tools. You know what is that? Root, GNU, and then Geo, Zebra. Okay, anyways, for new to me. And now you are talking about 1D, 2D as or 3D. I think even now you have heard about 6D and 8Ds also. Lot of our shlokas which are in ancient language by Sanskrit, they are converted when you chant that. It is a specific voice, variation, vibration of your throat and your voice. That can be clearly seen if you hear it in a 8D sound system. So now it will be very fascinating or glamorous to say 8D, 4D and all. That's what happened with your network, 2G, 3G, 4G. Now every common man knows what 4G is. If the 4G is not there, his system won't run fast. Now they are talking about 5G and 6G has already been in system. Now people know G, what are the G? Similarly, this 3Ds, 5Ds, 8Ds and all. That you will understand only by the graph. Physically, you can't understand. Okay, this is a 3D or a 3D system mask. But physically, how do you represent? I can't carry it wherever I'm talking or publishing the paper. So you should be thorough in reading the graph. A person who reads the graph properly and understands, he is a scientist, whether it is an engineering field, medical field, or any field. If you are not well diseased and the doctor sees some graph of you there, which you won't understand. Even your ECG, my ECG, I don't know what is it. Okay, if there is a pulse, peak pulse, it feels that my jinda hoon, I'm living. If it is flat, they say if it is flat, your heart has stopped. Then agar idhar touch karta ho to chal raha hai. So the frequency may be different. Oximeter nowadays. If your oxygen level is less, that can be detected in this digital system. Are you getting my point? What I'm telling is the sophistication of the system in the engineering field, scientific field and learning field. You should be aware of that. If you are not in phase with the stream, you will be outdated. Especially my senior colleagues, you know, we worked in DOS systems and PSpice softwares. After that, such a evolution has come down. My students will be knowing much more better than me. So at least to be a safer side in front of your students, to save your face, you should know certain things so that you can guide them also. No. So take the advantage of these 5 days, and we have eminent personalities like Professor Rana and Professor Roy. With my colleagues also, I think I have a few people in-house teaching also in different areas. 5 days, take advantage of that. Just don't do like your students or kids switching on your monitor on, mute, sound mute and video mute, and you will be doing your household work. That won't help. Either you be seriously working on that or you be absent from the system. Because these things are, okay, you might be facing this problem every now and then. You have these webinars and seminars and all. But you choose the one which you are interested in or which you need for your next generation work. I'm not talking next generation that way, next field, next semester. Because now in the next semester is becoming a next generation for you, you know. You are sitting at home. मालूम नहीं कब मैं बाहर जा रहा हूँ. When I'll teach students face to face. For senior people like me, it's very difficult to teach seeing myself on the camera and all. You're all young, now you get inculcated into such system. This is what is going to happen in future also. If they find it very budgetly cheaper, doing this type of things, everyone will go for that. So there's no need of flying and all. So you can't be doing along with the faculty development program sightseeing nahi ho sakta hai. Correct. Otherwise, everyone would have been loving to come to Jaipur. Jaipur is a tourist destination. Chalo, along with the tools of software tools, I can take tools from Jaipur tourist place. But now that is not possible. You have to stick to your monitor and hear and study. So all the best and take the advantage of that again. I congratulate all my colleagues from 3 departments and the coordinators and the conveners. So good luck. Thank you.
Thank you, sir, for your encouraging words to the participant and the faculty who will be involved in this STC. Now I would like to ask Sarthak, Dr. Sarthak, from coordinator from ECE department, to welcome and introduce the guest of honors, Professor I.K. Rana and Professor Anki Roy, who are connected online. Yes.
Sarthak, you are not audible.
The mic is muted.
I, Sarthak Singhal, faculty in the Department of ECE, MNIT Jaipur, feel privileged to welcome all the participants in the first day of this online STC. Now I would like to introduce our first eminent speaker, Professor I.K. Rana, who is the guest of honor for this event. He has worked as a professor in Department of Mathematics at IIT Bombay during 1984 to 2015, and thereafter he rejoined there as an emeritus fellow till 31st July 2020. He is the president of Association of Mathematics Teachers of India. He has authored and co-authored several research publications in international journals and 4 books. He has been awarded C.L. Chenna Mathematics Award in year 2000, Excellence in Teaching Award by IIT Bombay in year 2004, then Aryabhatta Award by All India Ramanujan Math Club India in year 2012, then Nalini Bala Lifetime Achievement Award at Technology and Innovation Mathematics Education 2019 conference. He has developed interactive web courses on calculus, linear algebra, and video course on major theory, which is available on YouTube. I once again welcome Professor Rana sir and invite him for his remarks and to motivate the participants. Welcome, sir.
Thank you, Sarthak, for your pleasant words about me. Normally, I only show my screen and then do something with it. Is it okay for everybody if I present my screen for 5 minutes? And then I will speak along with it also.
Definitely, sir.
Yes.
Yeah, are you able to see my screen?
Yes, sir. Can you make it full screen, sir?
I will try to enlarge it as much as possible.
Okay.
Yes.
Okay.
Yeah,
Thank you.
I think that's good enough.
Yes.
Yeah, so welcome to all the participants for this 5-day long workshop. And this is a Google age. I would like to call this age as like we had the Kali Yuga and other yugas. For us, it is a Google age. What does that Google age mean for us? Google age is a search engine. Google is actually a search engine, but it's much more than that. There are Google Docs, Google Sheets, Google Slides, Google Forms, Google Sites, Google Blog, and YouTube also is a part of Google now. Google Maps, Google Earth, Google Fiber, Google TV, and it goes on. Now Google is playing a very important role in education, and what we are using is a Google Meet, where we're doing online teaching actually. So this is the Google age. But I would like to caution, I would like to show you a small cartoon which says a teacher is saying to the teacher that once I learn to use Google, isn't that all the education that I need? So that is a misconcept, the technology or Google. I've taken Google as an example, and don't think that if you know the software, you know the subject also. So that is the implication for us in this present scenario. Google creates the illusion of accessibility. It's a linear search engine. So that's not a very good way of searching actually. It says answers, so it kills curiosity and inquiry. Google does not tell us how the information is discovered. Only the information is given to us. Right? So that is like ready-made food is served to you, not how it is made. Google promotes the blind copy.
Are you changing the slides? We are not able to see.
Rana sir, sorry to interrupt you.
Yes.
Are you changing the slides?
Yes, I'm presenting my screen. Is it not visible?
No, sir.
Your
the
cartoon has not seen.
Oh, is it?
Yes, sir.
No, but somebody said my screen is visible. Somebody said make it full.
Only screen is visible and only the first slide is there, sir.
Is it? Because I am changing slides here, that should be visible to all.
No, it's not being done.
Okay, so let me stop and then do it again.
Yeah.
I will. I'm sorry if it's not visible because somebody said it is visible, so I said okay.
The first slide is visible.
Just a minute.
Only first slide is visible that time, sir.
Okay. So I'm going to change the slide. You please tell whether it is change is coming or not. Next one.
No, sir.
No, sir, only the first slide is visible.
I think here only you see. Please welcome to the changes has to be done here on the administrator side.
Or if you have those slides with you can
All.
No.
Ask others.
Yeah, it's only first slide is visible. It is not changing.
Ask others.
It is not changing.
उनको हो रहा है बोल रहे हैं
Then
हाँ नहीं दिख रही, एक ही स्लाइड दिख रही है फर्स्ट वाली.
Next one now. Next one now.
No, sir, not yet.
That is very surprising because the first time happening with me in Google Meet that my slides are not visible because I have done it many times. I don't know. Technology can fail you sometimes. I don't know why it's happening. Do you see blank screen now? Black one?
no, sir.
only
No,
first
sir.
slide.
Only the first slide, sir.
No,
Okay.
Hello
that is
everybody. So can you switch off your videos? I think then there may be the bandwidth problem.
that's possible. If my presentation is not visible, then there will be issues later on also for everybody. I am presenting my entire screen.
No, sir, you switch off your video for a time being and share your slides only.
Ma'am has said that you should log off and then log in again. So should leave the meeting and then join again.
Oh, I should join again?
Yes, sir.
Okay, I can do that. If you want. But I am getting a message that I am sharing my screen do you see something else other than the earlier screen now?
So only the black screen is.
You are presenting to everyone.
You are presenting to everyone. This is
Yeah.
screen.
So I think it's a bandwidth problem probably at your end. Is it something issue?
Sir, you may switch off your video.
So you may switch off your video.
Okay, I will try to do that if you want.
Request all the participants also.
And it's a request to all the participants to switch off their video.
Okay, I have switched off my video.
Okay, now you click on the slides, sir. Please click on the slides. Yes, yes.
So kindly maximize the slides.
Are you able to see the next one now?
Yeah,
Yes.
first one is visible.
No, the first one. The next one, which there is a Google sign on it.
No, sir. Second slide is not.
I don't think it's a bandwidth problem because this video is coming clearly.
Yeah.
It's not a bandwidth problem. Something else is happening.
So kindly scroll down your PDF.
I am scrolling down my PDF,
It's not working.
but you are seeing only the first part.
Now, last chances you log off and
We have to go ahead with this without slides.
Sir, you can go ahead with the without slides. That is not a problem. Or
Yeah.
you can email us.
Okay,
You
sir,
can
it's
email
working
us
now.
Now it's working, sir.
Now it is
It's
seen.
fine.
Yeah, now we can see, sir.
Now we can see, sir.
You can see the next slide.
Yeah, second
You
slide
can
is.
see how Google impacts the way students think. That slide is seen.
Okay. I think it is getting stuck somewhere from your side because in transmitting. Yeah, this is the one I was showing. Are you able to see the cartoon now?
No, sir.
again is stuck. Sir, you please email the PPT to us. We will display.
Okay,
Sir, kindly email the PPT to us, this PDF, so we will present it from here itself.
There will be an issue. I can't send. I can send you the PPT, but all the other files you won't have it.
Okay. Supporting for
And it's
The drivers and all.
please speak.
Because I
Sir, kindly continue without the slides, sir. That would be better.
yeah.
During both of these talk, we can show those.
So we can show these slides during the expert talk.
I don't
Sir,
know.
maybe as a last option, you can just try to, log off and log on again, and that may work as a last option. Otherwise, we can continue.
Yeah, I think what you can do is you can continue with the next speaker, Dr. Roy, I think. In the meantime, I will log off and log in again because,
Okay.
It is fine, sir.
Okay, sir.
Yeah, that's
right? I think I will do that.
Okay.
Okay.
Because I'm seeing a very hazy picture of you all. I'm not seeing a very clear picture of you all sitting on the dais, no? So there is a problem, I think, about the bandwidth somewhere.
Yeah, ma'am.
The honorable director is not very clearly visible to me. It is an issue. I don't know what other participants are seeing. Okay, anyway, please continue.
Yes, sir.
I will sign off and then sign in again.
Okay. Okay.
Okay, ma'am.
Now I would like to request our next guest of honor, Professor Anki Roy. She is an associate professor at the discipline of physics at IIT Indore. She has done her PhD from IIT Bombay in year 2008 in hadron physics with CBELSA TAPS experiment in Germany. After that, she worked as a young scientist under the DST Fast Track project with WASA at COSY experiment Germany. In year 2009, she joined IIT Indore as an assistant professor, and currently she is involved with the ALICE experiment at CERN and CBM experiment at Germany and electron ion collider experiment at BNL USA. Her current research interest mainly lies in heavy flavor physics and detection simulation. Now I welcome her to motivate the participants.
Hello, everyone. Am I audible?
Yes,
Yes, ma'am.
Yes. Okay. Thank you for introducing me. So, Professor, Honorable Director, MNIT Jaipur, Professor Uday Kumar, and Professor Rahul Singhal, Head Discipline of Physics, and all the faculties, my students and staff of MNIT, and convener of the program, Dr. Kavita Lalwani, and all the participants of this course. I am delighted to be part of this program. Now, if I go or think about the motivation of this program, so one of the part is the train about this students about the software training of root, GeoGebra and GNU plotting. So regarding root, it is a software which is used by the high energy physics people and created by CERN. And India is an associate member of CERN. One of the main objective of Indian government to participate in CERN project is basically to train our scientists and students and learn the technology and software developed by CERN. So being a part of the CERN project, I am very happy that I got the opportunity to give a lecture or train our students through this program. Okay. I will not make my talk very lengthy because I am having a power problem in my place from the morning. Just 2-3 more sentences. Due to this pandemic, we are having lot of constraint in our day-to-day life. However, it has also opened up new opportunities or possibilities to just like for example, to run such kind of short-term courses online. So in this, if I have to think of such type of online course in physical presence, like the way we used to do it, so much travel we used to take, like thinking about the travel and all the hotel accommodation and so many stuff. So there is another advantage of having this pandemic, I would say, that sitting at home, we can participate or we can organize such kind of courses and which are very useful. So I will request all the participants to get maximum benefit out of this program. And another request, kindly interact and be proactive to ask questions to the experts or whoever is giving you training, because you are sitting in very far away places. It is very difficult for us to understand that how much you are understanding. Okay, so this is the request from the organizer side, from our side. So I will not make it lengthy. I wish all my students and participants get maximum benefit out of this program. Thanks all. Thanks a lot.
Yes. Thank you, Professor Anki Roy. So we heard, but yes. So thank you very much for motivating us that this root and the other softwares are associated with the CERN Geneva software, which are open sources. And I would appreciate that the students will now and motivated for attending all the hands-on training program. So we will also be connected for your expert talk after the inaugural session. Thank you, ma'am, for being with us.
Thank you, Kobita. So I will join when my talk will be there. I have some power problem at my place.
Okay, yes, yes.
Okay,
So
okay,
it is, yes. So
okay,
we are just about to finish, ma'am. So be connected if because we have to close this inaugural.
okay,
Okay,
okay. Thank you.
be
Okay.
connected. Okay.
Okay.
Sir, are you there? Professor I.K. Rana?
Yes, I am there.
So you can start, sir.
I can start my presentation, or what do you want me to do?
Yes, you can start as planned.
No, what is the plan? After the inauguration, I go for the 1 hour talk now.
Yes, you. The expert talk is after the inaugural session.
No, he said he will join along with that.
Okay.
Is it okay with you? During the expert talk only, he will do elaborate talk. If you want to do.
Yes. So, sir, you can speak few words now,
I will. Okay.
and then 1 hour talk after the inaugural.
Okay.
Okay. Thank you.
I hope my 1 hour talk also goes on well, because otherwise there is a problem about sharing my desktop. I will have problem in telling you what the software GeoGebra is, because all depends on showing something and interacting with you. So I hope I am able to do that. But this is an opportunity for you to learn about the software in a different mode. This requires a responsibility on your shoulders, that whenever some instructor is saying that please do this, you have to do it on your desktop or laptop accordingly and learn. Right? So I will appreciate if all the instructors are a bit slow and you are proactive in raising your doubts and saying that yes, we want to ask a question and say something. So let me just see if just a testing whether my screen works or not. I don't know, because if there is an issue, then we'll have to think about some other ways of doing our presentations. Somebody can respond to my question. What is visible on the screen now?
Sir, you are presenting.
Yes. What is? Can you read what is on the screen?
Still not. Just you click on your slide, sir. Yes, we can see what is ICT.
Okay. So ICT is, many of us use ICT, but we don't know what is ICT. It is information and communication technologies. So it includes many things. Okay. I'm just going a bit fast. You may not be able to read now, but everything is being recorded. So hopefully you should be able to see it slowly later on. Okay. So at present, the way we teach and learn is called behaviorism. Understand, remember, and reproduce. We need to change to what is called constructivism. This is for the teachers and would-be teachers. We need to change to something what is called constructivism, which means understand, acquire, analyze, and apply. How that can be done, technology can play a big role in doing that. And another reason why this is required, let us see whether this testing thing, I'm going to show you a small So next generation students is much more tech savvy than what we think we are. So be ready, and to be ready for the next generation, you have to be technologically savvy. So what I think is ICT, it is interactive classroom technology, a technology that brings interactivity in the classroom. And also for a teacher, ICT means I can show it something, be it a software, be it anything else, I can show it, that is ICT. The main aim is to tell you that technology is there, is for us to help us to teach and learn better. So all the best to all of you. Thank you, Ritu, and thank you everybody else for making me a part of this. So thank you very much. And with that, I wish all the participants all the best, and hope that when you, after 5 days, you will be much more tech savvy in many ways, more than one. Not only learning the softwares, but how to learn in a different way. Thank you very much.
Thank you, Professor Rana, for his inspirational work to motivate the participants. Now I request Dr. Venkat to invite the head of the department for delivering the inaugural address.
So, good afternoon, everybody. Respected Director Sir, today the Chief Guest, and the guest of honor, Professor K. Rana and Professor Roy. Now I am inviting Dr. Rahul Singhal, the Head Department of Physics, and the Professor Vijay Janyani, Head Department of ECE, and Professor Sanjay Bhatta Sir, Head Department of Mathematics. Please address this short-term course. Thank you.
Dr. Rahul, would you like to go first?
Yes, sir. Yes, sir. Yes.
Yeah, sure. Please.
Yes, sir. Yeah. So, Honorable Director Sir, Professor Uday Kumar Yalagatti, resource persons, Professor Rana from IIT Bombay and Professor Roy from IIT Indore. Convener of this event, Dr. Kavita Lalwani, Professor Vijay Janyani, Head of the ECE Department, Professor Sanjay Bhatta, Head of the Mathematics Department, Professor Rohit Bhaskar Sir, Coordinator TechCube, and other coordinators of this event, Dr. Ritu from Mathematics, Dr. Sarthak from ECE, and Dr. Anish and Dr. Venkatratnam from my Physics Department, participants and dear students. On behalf of the Head of Physics Department, MNIT Jaipur, and on my personal behalf, I wholeheartedly welcome you all for this 5-day online short-term course on software tools and techniques for scientific publication, Root, GNU plot, and GeoGebra. This workshop is being conducted through online mode due to COVID-19 virus, and this virus has changed our life completely. We should also see the brighter part of this, like now we have learned how to live together, how to stay at home without having junk food, just with the home food we are enjoying, and it has already been many months and may take another couple of months also. So in some way or other, we all are affected by coronavirus, and we all are following the guidelines issued by Government of India regarding this COVID-19 virus, such as wearing mask and have social distancing. And therefore, this workshop is also being conducted through online mode. Online mode, in my opinion, is always good because every time you cannot come in person. Suppose people are staying in other country also, they can also attend these type of programs online. So now regarding our physics department, we at the Department of Physics, MNIT Jaipur, we are researching all kinds of topics such as experimental condensed matter physics, plasma physics, accelerator science, cosmology, particle physics, high energy physics, and many other fields also. So in addition to teaching the BTech first year students, we are also running a master's course MSc Physics with an intake of approximately 34 to 35 students. And our all faculty of physics departments are guiding PhD research scholars in different areas of physics. And they are also doing sponsored research in terms of research projects, which are sanctioned from different funding agencies such as GST New Delhi, DRDO, CSIR New Delhi, ISRO, IUSC New Delhi, UGC DAE, CSR centers, Indore centers, Mumbai centers, and many other funding agencies. We at Department of Physics, MNIT Jaipur, are having projects of more than 6 crores, and many research students are working under these projects, and they are making their PhD thesis and availing the fellowship from these projects. So our department is having a journey of more than 50 years and is one of the leading departments in the country in terms of teaching and research. Many high-end research equipments are available in our department in various labs. To name few, like we have the thermal evaporation unit equipped with the turbo pump, we have the RF sputtering unit, we have high pressure measurement system for characteristics of different materials, we have programmable tube furnace which can go up to 1500 degrees Celsius, and many more. Like we have another setup of for sensing different type of gases and their behaviors. The faculty strength is also quite good at our department. We have total 14 faculties who are working in physics department, and in recent years there has been a significant development in our department, and all credit goes to obviously to our very dynamic director sir, Professor Uday Kumar Yaragati sir. Due to his dynamic leadership, in his dynamic leadership, we at physics department are growing like anything, and you know, we are having different projects from different funding agencies, so we are trying to develop the department from the external resources. Recently, MNIT Jaipur secured a rank of 35 all over the country in NIRF ranking conducted and issued by Ministry of HRD. It is all due to the collective efforts of the faculty of MNIT Jaipur. Now, this conference is organized by a team of faculty members from Department of Physics, Department of Mathematics, and Department of ECE, MNIT Jaipur. And this online workshop is on the software tools and techniques such as Root, GNU Plot, GeoGebra, and others. These are open access software. You can run this software from anywhere. I mean, on the Linux platform, it's very easy to run this software, especially like I have used GNU Plot. It's a very, very, vast software. We have lots of techniques in that. If you go for the non-open access software, like if you want to plot some graphs, then you have to go for Origin and all. If you see the Origin, a couple of months back, I wanted to buy a license of Origin. And I contacted to the Origin software persons, and they asked me that you have to pay something like 25 lakhs rupees for this software. Okay, it's not so easy to buy a subscription for each and every institution. But if you are using open access software such as like GNU Plot and other things, which you can easily run on Linux platform, then it makes your life very simpler, life of research scholars. You can easily draw your graph. You can easily do the plotting, the calculation of area of different curves, everything you can do here. The only thing is that we should be aware about these softwares, that these softwares are also available and we can use them freely without paying any charges. I hope at the last, the participants will be highly benefited by this online short-term course on the software tools. I would like to wish a great success to all the conveners and coordinators for this event. Thank you.
Hello, good afternoon to all of you. I'm Vijay Janiani, head of the Electronics and Communication Engineering Department. Respected Director Sir, Chief Guest of today's function, Professor I.K. Rana from IIT Bombay, Guest of Honor, Professor Anki Roy from IIT Indore, Guest of Honor, Dr. Rahul Singhal, Head of the Physics Department, Dr. Bhattar, Head of the Mathematics Department, all esteemed faculty members, coordinators of this program, conveners, and all the participants. I welcome you all on behalf of Department of ECE and on behalf of MNIT Jaipur to this 5-day short-term course on software tools and techniques for scientific publication. And before I proceed, I would take your permission to switch off my camera just to save the bandwidth. So I'll continue now. And as the title of this STP is very interesting, because as we are all aware, we are from scientific community, that conducting research is very important in today's scenario and earlier also. But doing research is only not sufficient. It is only half of the picture. Presenting the research findings is very important. It is as important as conducting it, because this is how people will understand what procedures you have adopted, discuss the results and interpret the results and offer their feedback also. So I think this is a very useful course, and how to present the results, how to plot them. As Director Sir has already mentioned, it's particularly in today's scenario when we cannot see physically, when we cannot come in contact physically, this graphs they present, they give a, I mean, they have a lot of responsibility of presenting the results in an understandable way. Now, I would like to take this opportunity to brief something about the ECE department. The ECE department, the bachelor's course started in electronics and communication engineering first in 1984. Initially, it was an electrical engineering department. Then in 1994, it came as a separate entity. And it is one of the largest departments of the institute as far as the number of students and number of faculty members are concerned. Currently, department offers 1 UG program and 4 PG programs in electronics and communication engineering, VLSI design, wireless and optical communication, and embedded systems. And department also offers a PhD program in all relevant areas. And the department has been receiving numerous grants and projects from various reputed funding and semi-government agencies, such as DRDO, MHRD, AICT, Ministry of Information Technology, UKRI, DST, and ISRO. The Department of ECE at MNIT Jaipur has a blend of young as well as experienced dynamic faculty members. And the motto of the department, I mean, it's committed to providing quality education and research in the field. And before I stop, I would just like to mention that recently we received a grant of 1 crore 25 lakhs rupees from Ministry of Science and Technology under the FIST program of the Government of India. So I once again welcome you all to this short-term program, and I hope that with the nature of experts that are available to deliver this course, that talks, it will be very useful to all of you. Even I am tempted to attend some of the sessions, so I will try my best to attend some of the sessions. So welcome all, and thank you very much.
Sir, for motivating words for the audience that you will also join this course. So now I would request HOD Mathematics, Dr. Sanjay Bhatter, to address the audience for this workshop.
Chief guest of the inaugural function on the
Okay. The chief guest of the inaugural function, Honorable Director Professor Udai Kumar Aryagati sir, guest of honors, the inaugural function, Professor I.K. Rana, Professor Anki Roy, the member of the organizing committee, my dear colleagues, friends, and participants. Good afternoon, everyone. On the behalf of Department of Mathematics, I welcome all the participants in the STC on the software tools and techniques for the scientific application. I hope that this 5-day online short-term course will be useful for all the participants, as the topics and tools selected for the STC are quite relevant and effective. In the mathematics department, presently 9 regular faculty members working, a large number of research articles and published in the national and international journals and conference by the faculty members and research scholars. The department has produced more than 40 PhD theses so far in the various areas of mathematics. At present, 18 students are pursuing further research. Again, behalf of the Department of Mathematics, I wish you all the participants to have fruitful deliberation and discussion. I hope you will enjoy in this STC. Thank you very much.
Thank you, sir, for your motivating words to the audience. Now I would like to invite Dr. Rohit Thakur, who is the coordinator of TQ, because this course is sponsored by TQ. So I would request Dr. Rohit Thakur to address the audience and motivate. Please there, because we have some problems with technical issues. So please be connected.
Respected Director, sir, Professor Udaykumar, sir, guest of honors at IIT Bombay and IIT Indore, various participants participating in this short-term course. As a coordinator, I would really like to submit that we are following the vision of the Government of India. And Mr. Modi, I remember about 7 years ago, he had made a call for the skills and the skills scientists and all the people across the country. As decades in development has been a major goal that we want to attain. Also, organizing during this COVID time also, our basic aim is that people should not be simply sitting idle, and we should try to gain as many skills as possible. And these interdisciplinary skills, which possibly could be part of jointly organizing, we find it could be useful to all the scholars coming from multiple streams. So the benefit of these courses, no doubt, would be for students across all the spectrum of departments. Further, the threat of this short-term courses on the software which are freely available over the last few years and recently also to see that the knowledge, that is the domain knowledge that's with the different companies, that has to be broken up. While we see that apps are being banned in different countries, the challenge that some of the knowledge and data, it is being owned and constituted by certain countries. To break that, and as a nation to grow, the need of the hour is that our scholars they should be accomplished. They should be which are freely accessible. And as a scholar, as a student, as an institute, the students can perform the very best and come out with the skills that they can learn from these short-term courses. So I guess the learning during this period would be quite interesting, and people would be able to gain something which possibly they can share with their students in the future as well. I wish everybody a good learning period, and best wishes to the organizers. Thank you.
Thank you, sir, for motivating words. And definitely, many students, I would add that many students have installed the software. We have sent the scripts and they are happy to install it. And they are waiting for the hands-on lectures and invited speaker. So now I would like to, so we are connected as a virtual, at the virtual platform. So I would like to still present e-memento for the chief guest and guest of honors. So I would request to our HOD physics to present the e-memento to our director, sir. So please be connected. Present the screen first.
Download.
Okay. I can
ओपन जो एक्स्ट्रा विंडो को एक बंद करके तब ओपन करके देखो पहले से
present the screen.
Hello, Kavita.
Yes.
Can I request that please announce all participants, please keep their mobile switched off. Otherwise, there is a echo coming and then it is disturbing the audio from everybody. All participants, please switch off your mobile or keep it on silent mode.
Okay. Thank you, sir. Okay, so this is the e-memento we are presenting on the screen, which is given by HOD Physics. So, sir, just present to the director, sir, who is the chief guest of this program.
Yeah, this memento is presented to our honorable director, sir, Professor Uday Kumar Yaragatti, sir. So it's a e-memento. Thank you.
Yeah, thank you. I accept it.
Okay. So just be connected. I can understand this is difficult to be connected while we are connecting online. Okay. So now I would like to invite HOD Mathematics. HOD Mathematics to give the memento to Professor Anki Roy.
Professor Anki.
Okay, so this is visible to the screen. So
I presented the e-memento to Professor Anki Roy.
Thank you, sir. I accept it.
do your presentation. Okay. Sorry. Just wait. So Anki ma'am, can you see your e?
Yeah, she said.
She has already accepted. She said accepted.
So sorry for the inconvenience. We are also learning with you, right? So now I would like to request Professor Vijay Jinyani, who is connected online, to present the memento to Professor I.K. Rana, who is the guest of honor for this program from IIT Bombay.
Thank you, Kavita. Yeah. Professor I.K. Rana, I present to you this e-memento, and we are very thankful to you for being with us today. So please accept, sir.
Thank you very much. Nice of you.
Thank you, sir. Thank you.
So now I would like to invite Dr. Ritu Agrawal, coordinator from the Department of Mathematics, MNIT Jaipur, to give the vote of thanks. Please be connected. Thank you, Dr. Kavita, for Honorable Director Sir and Chief Guest of the occasion, Professor Uday Kumar R. Yaragatti, Guest of Honors, Professor Inder Kumar Rana and Professor Ankhi Roy, Heads of the Department, Dr. Rahul Singhal, Professor Vijay Chanyani and Dr. Sanjay Bhattar, TechUp Coordinator, Dr. Rohit Bhagar, venerated professors, fraternal colleagues, and dear participants. It is my proud privilege and honor to propose vote of thanks on this occasion. I, on behalf of Malviya National Institute of Technology, Jaipur, and the entire organizing team of the short-term course, Software Tools and Techniques for Scientific Publications, Root, GNU Plot, and GeoGebra here together, and on my own behalf, extend a very hearty vote of thanks to all the speakers for gracing the event with your presence and took out valuable time of your busy schedule. I am really grateful to Professor.
Sir, audible to me. I can hear very well.
Okay, thank you, sir. I am really grateful to Professor Uday Kumar R. Yaragatti, Director MNIT, my NIT, to have graced this occasion and inaugurated the short-term course. His views are pearls of wisdom, and we would follow them in our endeavors to contribute more to the subject. Sir is a great mentor with positive attitude. I like to acknowledge our gratitude to the guest of honor, Professor I.K. Rana, for inspiring us with the precious thoughts. I express my sincere thanks to the guest of honor, Professor Ankhi Roy, for providing us encouragement by the great words of wisdom. I must mention our deep sense of appreciation for our HODs, Dr. Rahul Singhal, Professor Vijay Janyani, and Dr. Sanjay Bhattar, whose unflinching support in organization of such events cannot be expressed in words. Their constant support is what motivates us to come forward for organizing such events. We gratefully acknowledge the financial support by TechUp Phase 3. For this, I especially thank Dr. Rohit Bhagar, TechUp Coordinator, for guiding us in preparing the proposal as per norms and related step-by-step direction. I thank all the participants of the workshop for recognizing their zeal for learning by participating in the short-term course. Well, friends, an event like this cannot happen overnight. The wheels start rolling weeks ago. It requires planning and a bird's eye for details. We have been fortunate enough to be backed by a team of very motivated and dedicated colleagues who know their job and are result-oriented. I like to thank Dr. Kavita Lalwani, convener of the STC, for taking the initiative and working hard from planning to execution of the things. I cannot thank everyone enough. I thank Dr. K.V. Kama, Dr. Sarthak Singhal, Dr. Anis Ansari, coordinator the completion of tasks. I want to state that we are all most grateful to all speakers on this made this inaugural session a success. I thank you for being here this evening. It's been a great pleasure. Thank you very much. Thank you, everyone.
Thank you.
Thank you. Okay, so we are now will take a 5 minute break and we'll start our expert talks. Okay, so please be connected.
Kavita, can you stop sharing your screen? अरे इधर मैसेज कर रहा हूँ कोई हेलो these people are totally
Okay, can you hear us? Yes. Can you hear me? Akshay, can you hear me? Okay. ये भी ऑफ कर देता हूँ. Okay, so can you hear me? Is that clear now? Okay. So sorry for the inconvenience. Now, Professor I.K. Rana, are you ready for the talk?
Hello. Yes.
Yes. So you can share your slides now.
Let's hope it works.
Yes, yes, it will work. So we are here we are here. You can share your slides, sir.
Yes. Who is coordinating, saying that everything is visible or not visible? Is it Kavita?
Yes, sir. So you can share the slides, sir.
I have already shared my screen.
Okay.
Is it
Yes,
visible?
sir. It is saying that it is presenting. So maybe it will take some time to display your slides, sir. Should I disconnect? I'm not connected. So he is connected. Okay.
I am connected. I am sharing my screen.
Yes, yes. So, sir, you can just click on your slides.
Is something visible to you? What is visible?
It is just your screen that you are presenting. Can any Akshay, can you confirm that are you able to see his slides? Maybe is the problem from our side. Can anyone confirm?
Can somebody confirm whether the first slide is visible or not, with the title written as GeoGebra and my name on it?
No, no, sir.
You can type in chatting it.
Yes, now we can see.
Yes.
Now we can see.
GeoGebra.
So, sir, please go ahead with the slides.
I hope, I think it's an internet issue at your end. It is a bit slow probably. So
Yes.
it's taking time to load.
Yes. So actually here weather is not good today. So you can start. Now we can see. Okay, sir? Okay.
So after the break, let me welcome you back to this session on GeoGebra. I don't know how many of you know it about GeoGebra or not, but this is a combination of two topics. The first three letters are from the geometry, geo, and the remaining 5 letters are from algebra. So geometry and algebra are combined together to give a software called GeoGebra. GeoGebra is basically a software which is written in Java, and it was, you'll be surprised to know that GeoGebra was the PhD thesis of a student in Austria, a university in Austria. This was he developed this software for his PhD program, programming in Java, and it has now become such a it's an open source software. So it has become so popular with schools and colleges all over the world. That is a really surprising thing. The reason is this is a software which is very easy to learn and very easy to use in many ways. So we'll be today in 1 hour talk, I'll be trying to give you some glimpses of this software. So let us go ahead. So the first thing we like to ask is, what is GeoGebra? GeoGebra is a free dynamic geometry software. It is a free software. It is open source software. It can be downloaded free. I will tell you how to download it. It can be downloaded free. It can be used freely for any academic purpose like any other open source software. It can be modified. Even the scripting is available for the source code is available for the software. One can get the software source code and do some modifications if you want to do. But at present, that is not our aim. Our aim is to get an exposure to the software called GeoGebra. So this software GeoGebra can be used for teaching and learning geometry, algebra, statistics, calculus, and graphic spreadsheets. So I'll try to give you examples of each one of them one by one. As far as the pedagogical outcomes are concerned, it can be used for illustrations, it can be used for explorations, it can be used for modeling, and so on. It has many capabilities which can be. Let me just show you something. It'll take some one minute to load. So what I showed you was a small clip in which is actually made in GeoGebra. So it has a lot of geometry. It has a lot of what we use in the clip was rotations, reflections, translations. These are all linear. Some of them are linear transformations used in linear algebra. So a lot of linear algebra can be learned and taught using GeoGebra. So let me begin with the beginning. If you want to download and install GeoGebra, you have to open your website. You have to go to the website. It is called geogebra.org. Download. Even if you don't know this website name, does not matter. You type in the probably let me just do that. You type it in the web browser. In the Google, if you type GeoGebra, so GeoGebra.org will be the first thing that you find, and you click it, you get to the site GeoGebra.org, and here there is a downloads section in it. You click the downloads, and once you click the downloads, there are many versions of it available, but which I find very convenient to use. And
Professor Rana?
Yes.
Actually, your screen is very small. It's not the full screen.
It's the full screen. Are you using a laptop?
Yes.
Yeah, it should be visible. I am full screen on my screen.
Okay, no problem.
Yeah, so I don't know what is the issue coming, but I am full screen on my. I'm sharing my desktop, full desktop.
It's okay.
Right. So let me go ahead. Maybe there is some. So once you click this download, you will download the software. So let me go back to my slides. So here is that what I showed you on the website. You click this download and you will get, you save the file. The file will be GeoGebra Windows Installer 50536, and then you save it on your desktop and you install it. Once you have installed the software, when you click, so this symbol will appear. This is a very important kind of a symbol which will help you to recognize GeoGebra software. This is a logo. It has got 5 small circles intertwined with a string. So this kind of a symbol you will see on your desktop. You click that and the GeoGebra software will open. So this is the interface that will open. I'll just show you that. So let me, so for example, let us click that, and this is what GeoGebra will look like. So here is the full screen, and let me make slightly bigger so that font size 18. So when you click the GeoGebra, you will see this following thing will appear. It has 2 sides. One side is called the algebra side, that is on the left. On the left of the screen, at the top you see algebra written there. On the right hand of the screen, there is graphics written here. So whatever we do on the graphics window, on the geometry part, that appears as a algebra on the left hand side, and whatever we do on algebra, that appears on the right hand side as geometry picture. So that is the basic interface. So let me now show you what are the things possible you can do. At the top, there are some commands like file, that is opening a new file, saving a file, and so on. There is something called edit, that is trying to do, undo, and redo things. View, you can view the algebra part, that is on the left hand side of the screen. You can view spreadsheets if you want to do some statistics. You can do something computer algebra system. You can to have 2 windows, graphics 1 and graphics 2. You can have 3D graphics, and some other things are there, which slowly you should come to know when you are doing using GeoGebra. Then view, there are options of changing rounding of decimal places, labeling, and so on. Okay. Then there are customizing tools. So that is one part of. The important part of GeoGebra is this middle portion, which is called the toolbar. So this portion is called the toolbar. The first one is move. It is like moving the objects. Object is something that you have constructed on the screen. So I will slowly, for example, let us look at this is using these tools, you can create a point. You can create a point on an object. You can attach or detach a point. You can intersect 2 objects. Midpoint or center of something. You can plot complex numbers. You can find extremums, maxima, minima, and you can find roots of some graph. Right. So let me start off with something so that you don't get bored a bit. So let me select the tool called point. So on the point, I have clicked the first one, the point. So I have selected a tool which will help me to create points. So how do I create a point? This is the geometry panel. This is a geometry panel. I click anywhere, a point is created and it is named as A. So a point is created and it is named as A. I'm still, my point tool is selected. I can create another point, say a point as B. Okay, on the screen. And now you see the interesting thing what happens with respect to this axis on the screen. The coordinates of the point A are shown. The point A has got coordinates 4, 4. Okay, and B has got coordinates 1.8, and X coordinate is 1.8 and Y coordinate is 0.72. Now, why it is called dynamic geometry software? The reason is the following. Now, let me go back to my tool, which is the move tool. I select move, Now you see this point A, which I have plotted. If it was a paper and a pencil, I can't do nothing about it, right? But in this software, I can move this point anywhere I like. And as I move this point on the coordinate axis, the coordinates of that point are changing and the changed coordinates are appearing. So the point A, I can change anywhere I like. Similarly, the point B, I can change and anywhere I like. This is only a demo lesson. Otherwise, I would have asked you to open your laptops, open GeoGebra, and go along with me to do this, learn this software. So this is A and B, 2 points on the screen, right, which I can move around. Are everybody able to see my screen? Hello? Are you able to see my screen or not?
Yes, sir, we can.
Yeah, but some participants are logging in and presenting. So my screen.
Then you forward to us, eh?
Yeah, we have our.
Somebody has stopped. Somebody is presenting, so my screen has gone bad.
आप ही लग रहा है मुझे तो के कविता लालवानी.
So please, no participant should start presentation. No participant.
है ना? या मैं प्रॉब्लम उसमें नहीं आती. मैं कैसे प्रेजेंट करूँ?
And please keep your mic switched off. Your mics are on. I can know what you are talking about. Please keep your mic switched off. Don't present anything. Keep your video switched off. Otherwise, you will be disturbing. And once you have started presenting, my presentation is gone. Okay, I have to resume my presentation. So let me resume my presentation. So let us come back. Is my screen visible? GeoGebra panel visible?
Yes, sir, visible, sir.
Okay, good. So I was telling you this is a dynamic geometry software. These points A and B all can be moved around anywhere I like. Okay, right. Now, since I have already opened this software, let me go ahead and do something more. We learned a theorem in school level geometry saying that the medians of a triangle are concurrent, right? So let me probably just to begin with, as an appetizer, show you that. So let me construct a triangle. So let me remove all this things. I can highlight and remove them. So let me construct a triangle. So here is a polygon tool which will help me to construct triangles. So you know, polygon is a figure which connects points. So let us draw a polygon. 1 point here, 2nd point here, 3rd point here, and this is a triangle that I have constructed. So using this polygon tool, I have constructed a triangle. So what GeoGebra has done on geometry panel, it gives me a triangle with vertices. On the left side, you can see the coordinates of the vertices. Opposite to the angle A, it gives me the side A, small a. So this BC is named as small a, and side AC is opposite to the angle B, so that is named as small b, and similarly small c. And not only it gives me this names, it gives me the lengths. The length of B, right, that is a segment. If I look on the left hand side, it is a segment joining C and A, and its length is 9.76. So A and C, this length is 9.76. It gives me the measurement and gives the algebra on the left hand side. Not only that, it tells me I have constructed a triangle T1, which is a polygon ABC. So T1 is this triangle, okay, ABC. And what does this 32.21 is? That is the area of this triangle. Not only it has given me the lengths of the three sides, even it has calculated the area and is telling me what is the area of that triangle, right? So much the algebra and the dynamic. Now, what is dynamic about it? I can move around this. It will still stay triangle. The coordinates of the triangle will change, the segments, the side segments will change, and the new coordinates will start appearing here, whatever they are. Right. So now let us try to verify the theorem that if I look at the medians of this triangle, they all should pass through one point. They should all be meeting at a point. So what are medians? If I take the vertex A and take the midpoint of B and C and take the line joining that, that will be a median. So let us find out the midpoint. For that, there is a tool here on the left side, midpoint or center. In the points, midpoint or center. So let me choose that, and I just click on this segment. It gives me the midpoint D. So what I have done, I have selected this tool, which is the midpoint. I have come back. I click on the geometry panel and I get E. I take the side AB and I click, I get the midpoint F. So I have gotten the midpoints of the three sides. What I want the medians. Median is a line, right? So I should go to this tool, which is called the lines tool. Is a line. A line is something which passes through 2 points. So take 2 points A, and where does the other line go? The line should pass through the midpoint, so that is D. So this is one median. So I have drawn one median. Let me draw the other median from the point B. It should go through this point. So what is this point? Let us find the point of intersection of these two. So intersect. What is intersection? I want to intersect this line, and that gives me the point of intersection, G. So G is the point of intersection here. G is the point of intersection of the two medians. Now what should happen? There is a third median. Where is the third median? It will start from C. It will pass through the midpoint F. If it passes through the midpoint F, the theorem says it should pass through the point G also, because then only all three more medians will be concurrent. So let us do that. So let us go to the line tool, the line from C. Now this is the line. Where should it go? It should go through the midpoint F. And as soon as it goes through the midpoint, you keep an eye on G here. As soon as it goes through the midpoint, it also passes through the midpoint, through the point G. So this illustrates the point, the theorem, that the medians of a triangle are concurrent. That's good. That's nice. But there is something more to it. There is a dynamics with it. What is the dynamics? Let me move. This is one triangle, but if I can move it, you see what is happening. If I move the triangle anywhere, if I change the triangle anywhere, the medians remain medians, and the point of concurrency remains the point of concurrency. The point of concurrency remains the point of concurrency. This is the advantage of the software GeoGebra at a school level. It's a very elementary application of GeoGebra at the school level, right? And not only that, in the left hand side, you see everything is being shown to me. Okay, it is dynamic. I can change the triangle, but the property stays intact, right? I can change A, B, and C. I can do many things. I can measure what is the length of AG, what is the length of GF, and then I can measure that this is 2/3 and this is 1/3 of that. All those properties are easy to verify using this software, right? Okay, let me go over to another example. I just want to show you illustrations and examples because this is, so let me, this one, if I like, I can save it. Okay, here is something which all of you may be interested in knowing. Either I can save it as a file and then it will be saved as a GeoGebra file. Okay, it will be having, it will be called whatever you want to give a name. Say for example, if I want to save it, file, save as, right? I can save it whichever way I like. It will be called welcome.ggb, or I can change the name here. I can change medians ggb. I can save that file. So this file is saved. For any future reference, I can bring back this file. I will show you that. But let me go to the new one. So I am starting a new panel, a new file. The old file is still there. Where is the old file? If I look at here, recent, the median.ggb, that file is still here. I can click that, it will come back. Okay. I want to go to a new one. So let me close this and come to the new one. Right. So the second example that I want to illustrate is something very nice. Let me do that. Let us take, so here is what I'm going to do. Let us take 4 points. Let me take 4 points, A, B, C, and D. All the 4 points, the coordinates are given here. Let me join them, A with B, B with C, C with D, and D with A. Let me join them. So let us join. So when you join, this is a segment. So I have gone here. I have looked at the segment tool, which is saying joining 2 points. Okay. So we join this with this, A with B, B with C, C with D, and D with A. So I have gotten a quadrilateral in the plane. Okay. So I can move it around anywhere I like. This is a quadrilateral. Okay, in the plane. Okay. What I want to do next is the theorem that I'm heading towards is about find out the midpoints of these sides. So midpoint of this side BC, midpoint of CD, and midpoint of DA. So I've gotten the midpoints of the 4 sides. Let me join the midpoints. So let me join. I'm using polygon tool. Okay. Purposefully, we'll see what happens. I select the polygon tool and I start with here and I join these midpoints. Once I've joined, this is what I will do in the classroom. I will ask my students, I took a arbitrary 4 points. I took the midpoints of the sides. I joined them. I got this quadrilateral in between. Do you see anything special about these quadrilaterals? The in between, the orange one, this quadrilateral. Do you think this has any special property? Probably let me hide the axis. Let me hide the grid because that is not important. Now, can you see and what is happening? The font size. Among the participants, anybody would like to say something? What is this quadrilateral? Can one person give me some reaction? In the chat box, you can put your answer. What do you think is the answer for this? I can't see the chat box here because I am not want to.
Sir, a parallelogram.
It looks like a parallelogram. Very good. So that is the visualization that it looks like a parallelogram. How do you verify it is a parallelogram? H1, F1 of the segments. Here is H1 5.09 and here is F1 5.09. So opposite sides are equal. G1 and E. This and this, these two are equal. Opposite sides are equal. Opposite pairs of sides are equal. That is characterizing a parallelogram. So that it looks like if I join the midpoints of a arbitrary quadrilateral, then I should get a parallelogram. right? But the interesting thing is GeoGebra, it is very dynamic. So let me move this point A. You know what is happening? My quadrilateral is changing. My quadrilateral is changing, but the inside one, that stays, right? That stays as a parallelogram. So this is dynamics. So that says whatever be my quadrilateral, if I join the midpoints, I will get a parallelogram. Now at this stage, I want to ask something beyond that, beyond this theorem, which I can do in a classroom is the following. I can ask, do you think this is a theorem about 2 dimensions or 3 dimensions or 4 dimensions? Do you think this is a theorem about 2D, 2 dimensions, or is it valid in 3 dimensions also? So just think for a minute and put your answer in the chat box. If you think it is only 2D, write only 2D. If you think it is valid also in 3D, write in 3D in your chat box. And whosoever is monitoring, please look at the chat box and find out what participants are writing and let them show. Yeah, here, probably I can see the chat box myself. Please keep your mobile off. I can't hear. I don't know other people are. Okay. Yeah, it's a parallelogram. Shashi is writing it is 3D. Can somebody else write whether it is 2D or 3D? Many of you are writing it is a 3D. Amit is writing it is 2D. Some are writing 2D, some are writing 3D. Good. So let me show you how technology can help. You're still able to see my screen, right? GeoGebra? You are able to see GeoGebra?
Yes, sir.
Okay, good. So let me go ahead.
Sir, yes, sir.
I am going to move this and keep an eye on this parallelogram. I am going to move A. I am moving A. It is remaining parallelogram. What happens if I move it on this side? What do you think is happening? Can you see this picture now? Do you think the points A, B, C, and D, do they look like in a plane? They don't look like in a plane. But still, E, F, G, H remains a parallelogram. Wherever be the points, it does not matter whether the points are in the 2D or 3D. See? This you can never show it on a blackboard. You can only show it on a software like GeoGebra. And many of you will think, I don't believe this looks like something it looks like a magic. No, it is that says there is a theorem which you learn that the midpoints of a quadrilateral form a parallelogram is actually a theorem about independent of dimension. You take any 4 points, A, B, C, D, join them, join the midpoints, and you'll get a parallelogram. Probably you still don't believe it is a 3D thing. So let me show you. Instead of locating it, let me show you another applet. Okay, so here is the theorem that I was trying to show you. Here is another version of it, a 3D version. So now look, what I am showing you is capability of GeoGebra. GeoGebra has got not only 2 dimension. If I go view, what I am showing you is a 3D graphics. You can plot 3D things in GeoGebra. So these points A, B, C, and D, these 4 points, if I look at their coordinates, you see on the left hand side, from 2 dimension, it has moved to 3 dimension automatically, depending on whether you choose 2 dimension or 3 dimension. The point A has got coordinates, x coordinate 3.32, y coordinate minus 2.99, and third coordinate, z coordinate 1.47. Similarly, ABCD are points in space, not only in a plane, in space. And you can see this is the z-axis, the blue one, okay? The green one is x-axis and this is the y-axis, okay? And the interesting thing is I can move it. I can move the 3D version, you see. It tells me that this theorem is true for 3 dimension also. Of course, the theorem is true for 4 dimension also, but you can't visualize it. We can visualize only up to 3 dimension. But once you do vector algebra, you should try to prove this theorem that if you take vectors independent of dimension and take the midpoints, and that will form a parallelogram. So this is the version. I can move it. I can move this point. Geometry remains the same. You see that move tool is still active in this also. I can move it if I like, right? I can move it if I like, and I can visualize it. I can rotate and see. It stays. So this is 3 dimension. So what I have tried to show you is that 3 dimension capability of GeoGebra. Okay. Let me probably show you one more so that you feel a bit more comfortable looking at 3 dimension things. Let us go to a new one. I don't save it. So here is the 3 dimension. So once here, when you go view, if I select 3D, see there is selection, algebra, spreadsheet, cache, graphics, graphic. 2 possibilities of graphics are there, and third is 3D graphics. So I am having 3D graphics. It shows you see, the 3 dimension dynamic way. Okay. If I don't want to show the XY plane, I will simply, I can hide it, I can click it, I will see the dimension, right? So let me try to show you something. Okay, so here is a input bar at the bottom. See in this, go to the bottom, you see the input bar. Okay, I want to plot a 3D surface. So what are the 3D surfaces? For example, let us plot a sphere. What is a sphere? The equation of a sphere is x square plus y square plus z square equal to something. Okay, the radius square. So for the radius thing, let me create a slider. That will be a good idea. That will show you the capabilities of slider also. Okay. So let me 2D. There is something called a slider. What is the use of it? I will show you soon. Okay. So there is a slider. Okay. And what I am going to do is I am going to write the equation of a circle sphere. So equation of a sphere is x square plus y square. It is plotting. If I just write x square plus y square, only 2 variables. So let me probably, this is nice. Let me keep it as it is. So what I have plotted is a surface called x square plus y square. What is x square plus y square? Where is the z coordinate? The surface z is equal to hxy. That is the surface. It gives me the surface immediately. I can rotate it and see what the surface. Surface, if I look at from the top of z axis, it looks like a circle. Otherwise, it looks like a. So what is this surface called? This is called paraboloid, circular paraboloid, right? Why it is called paraboloid? It is like a parabola, which is either you can do it as a surface of revolution, or you can call it as, if I cut it, if I take slices. So probably let us take a slice. Okay, let me, it was x square plus y square, but let me change it a bit. Let me write another equation, x square plus y square plus sorry, Z, where is Z gone? Z, sorry, upper 2 equal to A upper 2. What I have done? Oh, sorry, I think equation is drastically not what I wanted. Again, a paraboloid, but let me change it, I think. Object properties. Let me change what I wanted was x square, or plus has come. So let me change it, plus x square x equal to, sorry, x square plus y square. I am modifying my equation is equal to a square. Yeah, that is okay. So here is the equation. You can see x square plus y square equal to z square. Or in the algebra panel, you can also see the equation x square plus y square plus z square equal to 1. What is that? If I remove it, I revolve it, it is that sphere of radius 1. What was the use of this slider? If I move the slider, you see what is happening. I'm getting that sphere whose radius is changing. It is radius is 2.8. Okay. I don't want to show my paraboloid. Let me hide it. So here is, if I click on the left side in the algebra panel, it will appear, it will disappear, appear, disappear. So there is a sphere. Okay. That is a sphere with, okay, you can see the sphere. If you want, you can keep the two. Okay. This is a paraboloid, that is a sphere. You can see the intersection of these two. Here is the intersection of these two. Let us see whether the intersect tool works or not. Intersection of this with this. See that portion of, you can't see it that clearly in 3 dimension, but intersect this with this. Okay. So you can see that thing happen. If I don't want to do that, I want to undo something. Here is a tool called undo. I can click it back. It is undone. So that is okay. So 3D. So I can see it back 3D. So you can see clearly what is the intersection of these two happening. Okay. So that is our capabilities of GeoGebra in 3 dimension. So let me see what more I wanted to show. I will come back to this 3 dimension probably a bit later if I have time. So this is what I wanted to show in 2 dimension of these things. Parallelogram, valid not only in 2 dimension, technology helps you to tell that it is valid in 3 dimension also. Everybody with me? You are able to see what I am showing you? Hello? Somebody respond?
Yes, sir. Yes.
Yes, sir.
Yes, sir.
Okay. Okay, good. Because I can't see you. I am on my full screen presentation. I can't see your faces. I can't see your chat. So I have to ask you. Okay, good. That you are not sleeping. Okay, let me go ahead. So there is something called in a classroom, how technology can help. It can bring in what is called iCube. What I call iCube is the inquiry mode. I think let me probably skip some of the things. So this could be an activity which can be done by a teacher, like I am doing something with you and trying to tell you. Okay. Or it could be something of your own. So what I mean by iCube is try to bring in inquiry in the classroom, try to bring in independent thinking in the classroom, and try to bring in interactivity in the classroom. If your class has got, as a teacher, if your class has got these 3 things, your class is very active. Everybody must be enjoying it. As a student, if you think your class is missing some of it, tell your teacher, please bring in these components somehow or the other. Otherwise, we're getting bored of your lectures. Okay, so let me go over all this mathematics. Probably you can read later on because it is being recorded. The main thing I want to do is, here is something called robotic arm in action. So this is technology and using technology to solve the thing. So here is a robot. Let me see if it works. So this is how I'll start an activity in a class. So here is an activity, a robot arm in action. So the aim of showing the video is that all the class starts looking at the video. So the attention is brought in the classroom. Everybody is attentive. So it has a uniformly expendable arm. So let me probably show you. This is what the robotic arm looked like. There was a base which was fixed. Okay. And there was a arm, and here was the hinge which was movable, and this was the place where it could hold something, right? So it could move left or right and so on. But what we are given is a special robot. We are given that a uniformly expendable robotic arm. The arm can expand, can become longer or shorter. In the video, the arm was fixed, of fixed length, right? There is a stationary control box which is mounted on the factory box, right? Factory floor, and the other hand moves on a assembly line. That hand is moving on a which is a control box, okay? And the middle point of that arm, there is a hook attached to it. So there is an arm which is expandable, which can become longer and smaller. One end of the robot is fixed on the ground. The other end is movable on a factory assembly line. The midpoint, there is a hook attached. So I hope the scenario is clear. So here is the scenario once again. And what we want to do, what can you say about the path that the hook will follow as the machine moves along the assembly line? As this moves along the assembly line, right? If it moves here, there is some length of the arm. If it goes up, the arm has to extend a bit up, down, right? So it is moving along a line. What will be the path of this midpoint? That is the question. So I give you 2 minutes to write down in the chat box what you think is the path traced by the midpoint of the robot arm. So please write down your reactions in the chat box. What do you think is the robotic arm? I'm yet to see any reaction in the chat box. Is the question clear to you or not clear? The question is, a robotic arm is moving, one end is fixed on the ground, other end is moving on an assembly line. The arm can become smaller or bigger. What is the What is the path of the midpoint? No? Oh, good. Somebody has written a straight line. One answer is there by Chitranshi Bakshi. Good. Anybody else would like to give a reaction?
उसको मैंने वो she is registered. Tomorrow. Hello.
Hello. Please keep your mic switched off.
Yes, sir. Hello.
Hello. Yes.
Sir, how much time? I think it's 5 o'clock.
You tell me when to stop. I will stop. So I will conclude and stop. Okay.
Okay, sir. Okay, sir. Okay, sir.
This is a Ram Katha, can go on forever. Okay. So this is. So let me show you. The path traced is a straight line, as somebody has guessed very well. But where is that line? So I can explore it in the GeoGebra. Here is GeoGebra. Here is the assembly line on which the arm is going to move. This is a fixed point. The point B is the fixed point. Okay. And this is the midpoint D. Right. So let me move this movable point. So this point, the robot arm can move up or down on the assembly line, right? And you can try to guess what is that path. Okay, let me hide the axis. Let me hide the grid. So if I move, if I want to show students very clearly, there is a possibility of something called a path of the point D. So let me click on that path and you will see various properties of the path. Okay. There is something called trace on. That means I will trace the path of D. Okay. So I have clicked and now you see what is going to happen. It will telling me the path followed by. So that says it is a line. Okay. Yeah. Okay. So I think with this short introduction to GeoGebra, let me come back and if any questions are there, I can take 1 or 2 questions. Is it okay?
So if any student have any question, please ask.
Please ask, either write in the chat box or ask. If you want to ask a question, you can ask a question if you like. If you don't like to ask a question, it's okay.
So sir, very nice presentation and very good learning, because the students are already replying, we can see, and you are all covering the answer.
Can we use it in physics?
So sir, the one question is by Naman Mathur. So where can we use it in physics demonstration? Any idea you can provide to the student that where we can use this GeoGebra or the exercises you have performed in the physics demonstration?
Yeah, I think Naman is asking, if you are serving a Italian pizza, can I have it or not? Can I have it in a village? Can I have it in a city? This is a GeoGebra has been used by physicists, astronomers, and many other people. I think I should show you the site where you can go and look for the examples. I think that is one important thing I should show you. Yeah. So in that same place where we downloaded GeoGebra.org, okay, there is a section on the left side called resources. So GeoGebra.org, that is a site. On the left side, you will find resources. If I click resources, you will find resources for many things, right? Resources for arithmetic, statistics, functions.
Sir, please share your screen, please.
Oh, my screen is not shared. Oh, I'm sorry. No, I thought It was on, so let me share my screen. Present now, entire screen. Okay. Yeah. So this is that site of GeoGebra, GeoGebra.org. So one from where you can download the software. Not only that, you can click on resources and you can find many resources here available. Okay. You can even type here GeoGebra physics. You see how many resources are possible in GeoGebra in physics. Okay. It says GCE O-level physics, sections of rectangular prism, and many other things. So you can search whichever is required, which is you can use it. But something, see, if you have got a knife, don't ask me where can I use it. If you need a knife, then only you should use it. Okay. And here is a book in physics by somebody. Okay. Here is another book in physics using GeoGebra. For example, if I click at that, I'll see table of contents, basic physics, scalar vector fields, magnitudes, kinematics, okay, linear motion, okay, exploration of linear motion, and so many things are possible. So these things are possible. You can time and distance graph in physics. They are very good examples of learning. S is equal to Vt, how will that things move, and so on. And there is another thing which I probably should have showed you is the following, that not only you can draw a graph, okay, you can even export the graph. So here is something called export. You can export the picture as a PNG or EPC, which you can include in your presentation later on, right? So for example, if I click at new, don't save, and I write here y equal to x square, so that is a parabola, right? I'm giving a very simple example, but there will be very complicated ones. I can change the color of this parabola if I want to change. Let me make it color as object properties, color as red, and make it slightly more bigger, thicker. Okay. Okay. Now, what I want to do is I want to take this picture and include it in my presentation somewhere, in a copy or somewhere, right? So what I do is I go to export. Here is export, and I click at graphic view. The graphic view will be exported. So this window will come. Okay, you don't have to.
Excuse me, sir.
Yeah, then you save it. It will save it as a.
So the screen is stuck. Screen is freeze right now. You're not able to see the screen.
Yeah, that is because at your end the network is very slow. That is the reason. So there is a possibility of exporting the picture. So let me close this and probably close this. And where is meet stop presentation? I think because there is another lecture, I shouldn't delay it anymore. Yeah.
Yes.
So,
Thank you, sir, for very nice talk and very nice learning on the GeoGebra. And the students are very happy to learn this. More they can learn in the during the hands-on by Dr. Ritu Agrawal, who is the faculty at MNIT Jaipur. So please, I encourage students to please join all the session. Thank you.
right.
Thank you, sir. Naman is also saying thank you. Yeah.
Yes.
So now I would like to invite Professor Anki Roy from IIT Indore. Are you connected?
Yes, Kavita,
yes.
I am connected.
Can you hear us? Yeah, so you can start the.
All the best.
Okay. Thank you, Professor Rana, for your nice talk.
So yes, we can see the slides.
Is it visible?
Yes, yes, yes.
Okay. So I can start now, Kavita?
Yes, yes, you can start. We are all connected here.
Okay. So one of the objective of this program is to learn the root software of CERN. So organizers or convener requested me to emphasize or to give the important features of root CERN software, and if it is possible to have some application in other fields. So I have prepared this talk. I tried to prepare this talk like this way. Okay, so whatever I am presenting in this talk, I have taken help from this root CERN homepage. So address is given here. And this is a very good documentation, I would say, for the root CERN, the best one, I would say. So you can, in this homepage, you can see already that how this install is coming. So here you can, if you click, you can see how to install. I have heard from the convener that you have already installed root software. So there you can see the get started button. So the basic how to start root, how to come out from the root, all these basic things you can see. And there is a another headings, that forum. So if you are an advanced C++ users, and if you are stuck somewhere, so you can ask in this forum about your problem, and there is a group of people who are quickly answer your or they will solve your problem if it is not already addressed in the forum. Okay, and you can see there is a nice manual about this root. I would say it is so good that sometimes you don't need any help. You can do it by yourself. Okay, and there are others like for developers, we don't need at this moment. So whatever I have presenting, basically everything is available in this homepage. Now, before I start, what are the basic features of root? So what is root? So it's a framework for data processing. Of course, it is developed at CERN, and this is the heart of any kind of, I would say, high energy physics research. Okay, and the first initiative was taken by another CERN scientist, René Brun and Fons Radmakers in 1994. And after that, it basically a lot of people, it started, it's a initiation by a collaboration. So they started developing this root. And the main program of this root software is written in C++. Also, when you will start using this root software, it is very much required that you should know C++. And this root software you can install in any kind of operating system. So operating system, I think some of the students are from undergraduate. So you understand operating system like Windows, nowadays Linux, Mac OS, these are the operating systems. So root runs all these platforms. So you can use any of your laptops, and you can, or desktop, that can, you can install root. Okay, and one of the most important part, this is the open source. So it is all the source codes are available online. So you can see how it is happening, how it is working, everything is there. And it is already, you know, all the softwares you are learning in this course, those are free of cost, as also this root is also free of cost. So you don't need to pay. Okay. So nowadays there is another programming language. All of you, I see that all of you are using this, that is a Python. So root also integrates Python with it. So basically there is a binding between Python and C++. So that helps us. So you have as it is root software in C++ language, and just you bind it with the Python, and there is a PyRoot code, and you can do, even if you don't know C++, you can use this root software, just knowing the Python itself. So as I said, this root software is dedicated, whatever the development has done, keeping eye on the research of high energy physics. Like I can give you CERN experiments like CMA, CERN, even other small high energy physics experiment. There are a lot of experiments. So their core software is root. Like the experiment is suppose Alice, then the main structure of this is the root based. So that software is called Ali root. So it is mainly used by the high energy physics community and heavily used, I would say. Okay. So since many of you are undergraduate students or master students, so what my plan of my talk is that I will introduce you what are the different features of root. Okay. So even if you are not a high energy physics student, because right now you are not selected or chosen your field of research, but if you are doing some kind of project or research, if I elaborate you on the different features of root, then you will be, you can decide, okay, this feature is available in root. Okay, that means I can use it in my research. I can do my work with the root. Okay, so I will try to introduce you different features of root, and also at the end, 1 or 2 slides, I will try to explain that what are the application in other fields. Okay, and finally, I will summarize and conclude. Now, application of root. Since this is a scientific software, so you can use it just like a calculator. This is the first application of root, I would say. And another feature, this root is basically C++ based source code. So you can use like to learn C++ or to run some code written in C++. So you use C++ compiler. So root software itself you can use as a compiler. That is one kind of use of root. I will say the very basic use of root. Okay, and this graphics, it is really in root, it is a very advanced level of and complicated graphics. But since you have, I have heard that you have hands-on on root, so this graphics part I will not cover in my lecture. And to do any data analysis, even if it is not in high energy physics, in any field, you need to, graph is very useful, histograms are very useful. Okay, so those features, how to do that in root, that I will little bit explain in my talk. Okay, there is a beautiful or very profound structure to handle data in root. That class is since I hope that you know C++. One of the main concept in C++ is that it has class structure. Okay, I hope you understand what is class. I assume that you understand class. So the T-tree is a class which can handle a huge amount of data very efficiently. So I will really go into details about this tree. And other than that, there is a T-math mathematical libraries under this root software. So you can do curve fitting that I will discuss. And also this is you can use it as a statistical tools for data analysis. Even if you are not a high energy physics student, you can, if you need some statistical analysis of your data, you can use it very nicely. Okay. And this 4-vector analysis, this is typical for high energy physics students. But if you are a non-high energy physics student, some other field, their 4-vector class also includes the 3-vector. So you can do the 3-vector algebra. And also root has matrix algebra operation. All kind of matrix algebra operation you can do it using root. Okay. And nowadays we all very much we are listening about the artificial intelligence. Also in high energy physics data analysis, we try to use machine learning, deep learning or neural network, this artificial intelligence tool, to discriminate between signal and background. So that tool can also be used in other data analysis if you want to use it. Okay, so that also I will explore in my talk. So histograms in root, if you see this structure, so TH1, This is the base class of the histogram. And you can see it can handle TH1 means it is a one dimensional histogram. Then you can see TH2, it's a two-dimensional histogram, and TH3. So this is a three-dimensional histogram of all kinds of data. So it can be integer, it can be character, it can be string, it can be float, it can be double, and so many things. So I can summarize here using root. Of course, in the hands-on, I think they will you will get how to do this, how to draw histogram in root, that you will learn. But at this moment, you learn, you can just know that it is possible to draw all the one-dimensional, two-dimensional, and three-dimensional histogram using root. Okay, so D means it is the dimension. Okay. Now, this I just to show you that here in this left-hand side plot, it's a one-dimensional histogram. So you along the x-axis, it is the some variable you are plotting. In this case, in the black box, you can see that it is some random number which is producing from the Gaussian structure. So that is filled in this histogram. So this is the value of this parameter which are filled here, and along the y-axis you can see 50, 100, 150. These are the number of times you have filled this histogram. Okay, and in this right-hand side picture, basically it is a two-dimensional picture. You have along x-axis you have px, along y-axis it is py, some variable. At this moment you no need to go in that details. You have generated those numbers and filled it, and you can see the third dimension is basically your counts. How many times you have filled this structure, filled these variables. Okay, so just it is possible to create 1D and 2D histogram in root. So first what you have to do is you have to define a constructor for a particular type of histogram. Constructor is a typical word basically in C++. So if you want to create an object of that particular type of histogram, you can first you can see th1f h1. So this is the line you have to write, and then you can fill this histogram. You can see that you are filling by some Gauss and 10,000 whatever, 10,000 times you are filling this one, and then the third line it is you are drawing that histogram. So these are the comments. So you have to, if you are familiar with the C++, then these are the comments you have to write, and then you can plot all these histogram. Okay. Now there are so many features of in root to plot a histogram. It is quite impossible to cover in 1 hour lecture. So what I will say, just quickly go through that. You can, if you have two histogram, you can add. If it is certain characteristics, you can add, you can multiply, you can divide the histogram. Those kind of operation is possible using root. You can superimpose two histogram in another new histogram. You can do that. And there are different drawing options. I would suggest you just try to play with that. There is a very good tutorials. So you just play with that, all these options. Like you just draw, and if you write if you write same, if you write cylindrical, how this your picture or whatever histogram you are drawing, how those are changing. So it is not possible to cover in a lecture. So these are the, I'm just telling that there are different options available in histogram using root. Okay. So now I will talk about the graphs. Okay, so what is the first of all, what is the difference? You maybe some of your undergraduate students, you may be confused with it. What is histogram? What is graph? So graph, you can say you can do the plot of your array of numbers x and y coordinate, and there are certain number of points. So this is a kind of, you are directly plotting that data. You are not doing any segregation of your data. Whatever your data you have, you are just plotting. In scientific language, we say this is just unbilled data. I am not doing anything. Whereas histogram, it's a, you have large number of continuous data points. What you do, you try to bin them. So, okay, if my total range of data is suppose 0 to 100, Okay, so that one, what you try to do, okay, you try to make a small, that 0 to 200 or 100, you just bin it maybe 50. So 0 to 2 will come in 1 point, and 0 to 2 to 4 will give you another point. This is called binning. So histogram, we bin the data, and in graph, it is a exactly original data without any changing anything. So this is a unbinned data. So in graph, I hope you understand what is the binning and unbinning part here. Other than this, in graph, you can do also you can plot. You can see this is a typical example of plotting of graph. So along x-axis, you have x variable. Along y-axis, you have some variable y, and n number of data points you have plotted, and those points you have connected by lines. Okay, so there are options of different other class options under this T graph. So you can plot also the error bars. How much error involved in your, mainly these are the statistical error, or if you are already measured some of other errors in your, I am not introducing, these are systematic errors also. So you don't know maybe in this at this moment what is systematic. Just assume at this moment some error with your measurements. So those error also you can plot in this graph. And also it is, you can see this T multi-graph. So you can plot more than one graph in one graph canvas. Okay, so that multi-graph option gives you that to do it. Okay, so there are different features. Again, the same suggestion. If you are interested, you go to the tutorial and do all the whatever the suggested, you do it, and you can learn a lot about this, how to plot T-graph and all this. Now I will cover basically the beautiful feature of one of the most beautiful feature of root, that is T-tree. Okay. So what is T-tree? So T-tree and T-n-tuple, basically it's a class, C++ class or under root, and which can, this class is designed in such a way that it can handle large quantities of data. Okay, same class objects it is written, means if the data are similar type of data or same kind of data, you can make a tree of it. Tree, you can use the tree class to make a tree. Okay, so tree, what is tree? Tree is basically a container. Basically, you can understand your container, you are dumping all your variables here. So this tree concept is very much useful for our high energy physics data analysis, like all LHC. So LHC is a basically Large Hadron Collider with a CERN experiment where this accelerator is there. So basically, there's all the experiments at CERN, we call it like LHC experiments. At this moment, we have 4 experiments. So what is the benefit of using tree? You can optimize or you can reduce your disk space. Your data may be very huge, but if you use the tree structure, then your disk, you can use very less disk space. Since you know in high energy physics, there are huge number of gigabyte, petabyte range of data they are producing. And if you finally save in your, save your data and which will reduce your disk space, so that is always encouraged. Okay, and if you use this tree concept, tree class to analyze your data, so it enhances also your speed of the program. Programming speed increases. Okay, so what tree, I would say that I will come in more details here. So you know the normal tree, our real tree. So it has a like different branches. So those branches are your different variables. So you are making for each variable, you are making one independent column. Okay, so those branches, columns are called branch. A tree branch class handles those branches. Okay, so it can you can contain huge number of data. And I have also, you can see in this graph, in this present slides, that I have also written here T-n-tuple. So T-n-tuple is nothing different. It is basically a T-tree, but when your data type is floating point, then it has a special name. It called T-n-tuple. Tree is the superclass. It can have any kind of, it can have integer, it can have string, it can have character, any kind of data structure, you know, different types of data. So T n tuple can handle only floating points. Okay, then it is a called not tree. You can use it T n tuple another class. So what is the advantage of using tree? So in this case, you have suppose similar kind of 1,000 events. Okay, so each event has suppose 10 variables. Okay, if you know C++ type of data stored, so if you have to read, suppose you have a 10 variables, if you have to do some analysis using suppose fifth number of variable, then what you have to do, you have to read all the events, 100 events, and you have to go through the all variables, and then you just collect all the fifth number of variable, and then you do your analysis. So you can understand if to do analysis only with a particular column or of particular variable, suppose fifth variable, you have to read the whole data set, and it takes time. It makes your program very slow, because you have to understand in high energy physics we are handling a gigabyte, terabyte range of data. So it is if it is a very fraction of seconds also, it can multiplied with that number. So it will be really, it will be some effective inefficient way of doing that. So to overcome it, what we do, we make a column of the data. So directly we can read that column, that is the branch of that tree, and I can fifth variable, I can make a branch and I can read that, and whatever physics I want to do, I can do. Okay, I think a little bit you got the idea what I want to explain you, but when you will do the hands-on, you will get more clear picture and you can understand. So there you can see I have written here, if you do not use tree, then you have to read the entire events. All the events you have to read, then you have to extract the parameters, then you do whatever you want to do. So it makes your program very slow and time consuming. Okay, I will come back to the usage of this tree, and maybe I will discuss at the end also. Okay, so here in this, there is a tutorial directory inside this root, whatever you installed in. If you go to this root system and then tutorial and tree, there is a one directory called tree. So tutorial, tree tutorial, if you see, there is a one nice example of how you can use, how can build a tree from an ASCII file. Okay, so in this file you have, there is certain database. So all the employees are there, their age group, and there you can see their category and whatever their how many children, what are their grades, different variables are there in that. So ASCII file, if you have, you just read that ASCII file. So this example shows how to read that, make a tree, T-tree from the ASCII file. So this data file is the CERN staff.data. So this is the database about the CERN. So you read that data and make a tree. And in this right hand side, you can see how you can make this. I will not go in details because there are so many variables. You can see small branches or leaves, you can see. So under this tree branch, so you have tree branch, and then you have under this branch you have leaves. So these you can see there are so many leaves of this. So these are the variables of your data. Okay, and in this left hand side figure you can see that you have plotted some along the x-axis age and along the y-axis cost. Okay, whatever the variable, we no need to go in details what is cost, all these things, but you can see once I have the branch or leaves, you can say here, I have age, branch or leaves, and also I have the cost. I will just take those two variables from this column, from this tree, and I will just read all these two columns and I can plot it a two-dimensional histogram. So no need to go through the entire database and read all the events. I don't need to do that. Also, this T-tree has a very nice picture. You can put certain conditions. Suppose you have a x variable in the right-hand side below, you can see that you can just see one comment that T draw. So tree is a basically tree of this tree object of the tree class, and you can see it is drawing X with certain condition. What is the condition? Draw X when X is greater than 0 as well as Y is also greater than 0. So any condition, if you put, you can do such kind of analysis. So you can write, okay, plot X when your X is greater than 25. That you can do. So you can play with just a small piece of code can give you the condition and you can do. So there are different, you can do also basically 3D plot, just do Z versus, like here you can see my cursors, I am plotting Z is then Y X. So this is a 3D plot, that also you can do. So whatever you have done in histogram, those features are also inside this T tree basically. So this is a very powerful tool to handle huge data set. I will come back to this point again. So to I no need to go in details about this because this is not my objective of my talk, but still I have show you one small piece of code if you can understand. So here in this first line, how to create a tree basically. So here I have given, if I am creating a file, you can see I have given this name test.root and recreate. So recreate means if it is already there, so it will delete that one and it will create a new one. So that is the meaning of recreate. And then you are defining a tree object, that is capital T, and you are inside this tree branch, you are defining 3 different branches. I am not going in that very details, but you can see X and then X. If you understand, it is a kind of address of X. You are asking for that, and X oblique then F. So F is basically you are telling X is a type of that variable. So it is a float. F means it is a float kind of variable. Okay. Now what you are doing, you are filling your T tree with these branches X, Y, Z, and you close and you close your file. So that will create, basically you will get a, if you run this code, you will get a test.root file, and there if you click, you will get a T, which is a T tree, and then inside double click, you will get 3 different branches, X, Y, Z. Now you do, if I go back to the previous one, so here you can do all the conditions, whatever you can apply, you can play with this small piece of code. Okay, so it is a very powerful class in root. Now, suppose you have a large number of root files. Okay, similar kind of tree is contents. So you have more than one root files. So no need to analyze those root file which contain same kind of tree. What you can do, you can chain them. So if you have suppose, so each root file, suppose you have 100 root files. So file 1.root, file 2.root, file 3.root. So all these root files have same kind of tree structure. Then what you can do, you can add all of them using this tchain class. I'm just telling you I'm not telling you do this at this moment. It is not possible, but just listen. What are the powerful instruments are there inside this root that I want to tell. So you can chain your all data, okay, and make a one root file, and you do the same kind of analysis which you used to do with only one root file. You don't have to take care. It will be automatically taken care by the program. So this is tchain is a very powerful class to basically club all your data. All your data, of course, it has to be same type of tree. Okay, you cannot do data from one event and some other object. You cannot just arbitrarily. It is not also the purpose of this tchain. You want to add similar kind of data. So that's why it is useful. Okay. So now I will go. So all of you are there?
Yes, we are connected.
Yes, okay. You have any question or anything? I am going too slow, too fast, or something you don't understand? Any question you can want to ask?
No,
Okay.
I think Anki ma'am, you are going very good way. We are able to hear you.
Okay, fine. Thank you. Thank you. Okay. Now, this is another feature of root, that is the library, mathematical library actually. So here, I will not go in very details as usual. I have another half an hour maximum to cover this. So I will just tell you what are the features available under this mathematical libraries. So there are different packages, I would say. So this one is, you can say, math core, another is math mode. So math mode is more details. I will not go in this math mode, but maybe little bit I will cover. And there is another linear algebra packages. So I can guess there are people who do lot of linear algebra other than high energy physics people. So it will be really useful for them. And there is also inside this math library, there is a minimization library. So this minimization comes when you do the fitting of a certain histogram. Okay, so this library is also available inside this TMath. And like we do vector, you know all the vectors, at least you have that idea what are vectors. So different kind of vector analysis operation you can do using physics vector class. And I will come to this unu.rand. This is also very advanced level of some random number generator. I will come later. Okay. Okay. So this math core library. So here you have, if you are a master student, you know the special functions. So under this math library, there are basically different kind of special functions which you can use. That is gamma, beta. Other than that, also you have math mode library. There you have all the kind of special function like Bessel functions and your Legendre function. All these functions you can use, because whatever those functions sometimes we use in high energy physics. So you know this, whatever it's done inside this, it is basically for keeping mind in the high energy physics utility. Okay. And also we have a different types of statistical function. So those functions used in statistics, such as probability density function, PDF, okay, cumulative distribution function. So you have a continuous distribution, you have discrete distribution. I think this can be used by the statistical analysis who are doing other than the high energy physics people. Like PDF, I know there are many other fields who use this. Okay, this here it will be used. Another thing, this numerical analysis, numerical methods, numerical techniques are also there in TMath library or math code library. You can do numerical integration, you can do numerical differentiation, you can find out root, and minimization I already mentioned. And this also possible, this one-dimensional and multi-dimensional minimization. You just know this thing. This even you don't have to go through the code, you don't have to do any practice. Just these are the features available in root. At least you know this. Okay. And another very strong tool I would say in root, that fitting and parameters estimation after fitting. Okay. This I will discuss in details. So this is also very frequently used by the high energy people. So anyone who is who wants to do different kinds of fitting in his own data. Even I would say that if you have some function, user-defined function also you can use for this fitting using root. This is a very powerful tool in root. And you will start loving once you start using this root software. But it is true also at the beginning, you need to be a little bit patient to understand the C++ coding and macro, all these things. After a certain time, if you start continuing, that will really help. So this math code library, which I was discussing, it contains TMath class. Okay, so if you are using the root class, and basically you can mention this TMath, if you are using some function like sine, cos, so then you can do this, you mention that sine function is under this TMath class. Okay. And I don't know how much you know about the random number generators. Like different fields, we use random numbers. So random numbers you understand. So it can give you any number. Okay. So it is random. Okay, there is no control. Ideally, it should be there should not be any biasing in the data which is generated. So T random is a class in root which can basically base class which can generate such kinds of data. But you can see I have written here pseudo random number generator. What does it mean? So this random numbers actually is generated by some logic. So it is not that way perfect random number. That's why we say it's a pseudo random number. There is, if you keep on generating random number using this T random class, then you will see after certain time there's random. You can understand there is some logic or if you are doing it. So it's not a perfect random number. That's why it is called pseudo random number. So there are other derived classes from this T random class, random 1, random 2, and random 3. These are very advanced level. I am not going to mention in details. And also there is another class. There is a field. It's called complex field basically. So there, if this T complex class is there, it can be useful for complex number operations. Okay, so T math, T random, T complex, all these comes. These are the classes which comes under this math code library, and this could be very useful for the people even who are not from the high energy physics background. So as I said, under this math code library, you have linear algebra packages. So this calculation, you do different types of equation solving, you do the eigenvalue problems and everything you can do using this matrix package. So matrix, suppose you want to do inverting a matrix. Suppose you want to create a matrix. That also you have a matrix class you can do. So you can set one matrix, you can get all the, do the operation, you can get the output. It is possible just if you know the C++ or root C++ kind of how to write a C++ code. Even if you don't know very much about the root, if you are familiar with this operation, matrix operation, you can use it. Like matrix decomposition, matrix eigenvalue. I know all the master students, they do mathematical methods, they do this kind of matrix algebra. So if you are doing your tutorials or this kind of job, you can check in your root nicely, quickly you can get the result. Like a matrix invert, how to do matrix invert. You just give your input matrix, set the input parameters of a matrix, 3 by 3 matrix, give the, and you can get the, just you use the command, you can get the invert of this matrix. So that is the, I am telling you the basic use of the matrix algebra, which you can do it. Okay, so this T minute class, I will not go in details at this moment, later on I will come back. So this T minute class is a class which does the basically minimization of the minimization technique. Okay, and it was earlier it was written in Fortran, and later on this René Brun, who is the father of this root software, he converted it into C++ class. Okay, and at the end, anyone is talking? Okay, so there is another special class of random number. Generally, random number, it's a uniform. It gives a uniform random number. Now, if you want a Gaussian kind of, or if you want a certain types of like exponential kind of random number, you just convolute your this random number object with this Gaussian function or your exponential function. Then it can give you the random number of that kind. So this was the space. But this unu.ran, it can give you the non-uniform random number. This is a special, it has a special feature. It can generate random numbers from continuous or multi-dimensional distribution. Okay, you have histogram, any arbitrary kind of histogram that it doesn't have any structure. That kind of random number also it is possible to generate using this class. So this is a unique features of the random number generation, I would say. And also the physics vector. So that vector algebra also you can generate, you can create your vectors basically 2D, 3D, 4D vectors using this gen vectors operation. you can do. So you can do the vector rotation. You can do the Lorentz transformation. You may not be aware of this, what is Lorentz transformation. It is a transformation of the four-dimensional, basically, space-time, four-dimensional transformation. This comes under the relativistic particles. So I am not going in that details, but it is possible to all these operations. So here in this gen vector, you can create your own vector. You can do all the operation transformation using this gen vector package. Okay, so you can do the modeling of your vectors. Okay, so I will quickly go through you can do different types of, do your work in different types of coordinate system, like 2D coordinate system. I will go quickly. Polar, you know, r theta, 3D r theta spherical coordinate system, or you can do in cylindrical coordinate system, and rest of these 4D coordinate systems, basically these are dedicated for the high energy implication, like we do your energy momentum vectors, that is a 4 vector. So these are the different, I will not go in details, but it has that kind of feature. So if you want to work in a particular kind of coordinate system, it is possible to do through these root features. Okay. Now I will discuss about this fitting of a histogram. Maybe I will, some of you may already be knowing what is fitting, but some of you don't know what do you mean by the fitting. So fitting is a method for modeling the expected distribution of events in a physics data analysis. So you have done some experiment, you have some data, it has some distribution, but you expect certain kind of distribution. Like you expect, okay, this distribution, according to my physics knowledge, it has to be a Gaussian kind of distribution. So what you do, you try to fit your real data plot with the expected distribution, Gaussian. Like in this case, you expect that the distribution should be Gaussian. So that is called fitting. You have a certain physics distribution you expect, and you have a real data. You try to match them. How much your reality is coming with the expected one. So that is called fitting. So in root is actually expert doing any kind of fitting, I would say. So you can do using fit panel. So basic kind of different like Gaussian, Lagrangian, all this fitting you can do, exponential, the normal kind of very familiar kind of distribution you can do using fit panel. And fit method, you can write the command and just you draw your histogram and just write histogram that H and then fit with your expected function. Even you can do your own defined distribution. No need to do with the typical whatever existing distribution. You can define your own function and fit with, you can fit your real data, whatever distribution you have got from the data that you can fit. So this is a very powerful class inside root, I would say. And I was telling, I was avoiding, you have seen that minimization package. So this minimization technique used when you are doing the fitting. So there are packages minute to few milli, all these packages, they are inside the root. Okay, it is basically used. It is not C++ version of this minute is developed by Rene Brun. That is fine, but the Fortran version is not the root features by itself. It is borrowed from the others. Okay. So you have, what is minimization? I will just explain in 2-3 words. So you have real data and histogram. You have plotted histogram. So you have each bean of the histogram. Okay, so in each bean you have the real data points and you are trying to fit with some expected one. So this depends on, it's called, you are trying to minimize, you are trying to optimize what is the best between this reality and your expected function. So you can understand that much at this point. So this minimization package is at the heart of this fitting class. So, this is very useful for the fitting purpose. And when you are doing fitting, you don't have to bother about this minimization. It will automatically display what is the chi-square. It is called least square chi-square minimization. So you will get that chi-square value and it will be fitted automatically. You don't have to connect with this minimization package. It will be automatically done. If you do just write command fit, it will be automatically done by that. Okay. And there is another special kind of library, that is RuFit library. It's a toolkit for modeling the expected distribution of events in a physics analysis. This is a special dedicated kind of library. It uses basically your log likelihood method. So you can do not only 1D histogram fitting using root, you can do 2D, 3D histogram with your user defined function. It is possible to do using fitting method in root. Okay, so this is in this slide I wanted to, so you just wanted to give you one example that in this left hand side plot you have a histogram, you can see, and just clicking business, you are just fit panel will, you can see this. If you do this right click, you will get one, you will get one this kind of this, and then what you can do, you can just click on this fit panel and you will get this right hand side one. Here you can write your this Gauss. If you select, you can other function also it will come out, and you can in the below you can see you can do all the range also you can select. So with the fitting panel also you can do very comfortably, you can do your fitting. And also the same without using fitting also you can do, you just write H1 fit Gauss. It will fit the this distribution will be fitted by the Gaussian function. Okay, there are a lot of sometimes this fitting becomes really difficult if it is not a really Gaussian type of distribution. Then you need kind of advanced kind of knowledge. But for the basic thing, it is very easy to do. Just you write fit Gauss. If it is distribution is really Gaussian like, it will be fitted, perfectly fitted. You don't have to do anything. Okay. And also this fitting business you can do for this, you can see this here. It is a multiple subranges. Means what I want to mean here, that you have one plot. You can see the right hand side upper plot. This is a you can see that it doesn't have any particular shape. But the physicist who knows that, okay, I expect here some kind of pi, or here I expect eta, or here I expect omega kind of measure. So what they will try to do, they will try to fit by some 3 different Gaussian. So multiple subranges you can fit with the different function. What I want to explain here. So here you can see 85 to I think around 98 or something you can fit one Gaussian. Then 95 or 98 to 105 you can make another pick. And here in 110 to 125 you can use another Gaussian function. So different range you can fit with the different function. That facilities are also there inside root. And in the lower below plot, you can see that this is a typical high energy physics analysis. You can see that there is this dot lines, this kind of data. This is black dots. These are data. What we are trying to do, we are trying to fit with the this. There is a basically peak. So this I called signal, which I am expecting. I want to get it. And the below, this is basically background. So we are doing this peak with the Lorentzian peak and the some kind of background fitting. Okay, what we do in the high energy physics, we subtract background and try to get the signal. So you can see that you have fitted with the combining 2 functions, Lorentzian peak and some quadratic background you have fitted. With these 2 functions you are fitting in the same plot. And then you want, as I said, in high energy physics, we are interested in the signal. So we subtract it. It is possible to subtract this background, and we subtract this background, and this blue peak is just my signal. So this kind of features are also available inside the root. Okay. So just to give you the what are the things available. So this is the, I just copied basically the multi-range subranges, multiple subranges fit, how to do, we do this one. So you can see I have defined here TF1. So this is a function class, TF1 class. So this is Gauss, and this 85 to 95, this is the range. So 85, 95 to 95, one Gauss, and then a 98 to 110, 108, 110 to 120. So 3 different Gaussians are fitted. So basically, if I go back to the previous plot, it is the program which I am showing, the which is plotting this right hand side upper plot. So you can just fit, and recursively you can fit, or you are fitting one, then you are adding with the other one. And another features, not only fit, all the fit parameters, like you are fitting with the Gaussian. So what is important parameters for a Gaussian? You know mean. What is the mean of a Gaussian? What is the sigma width of the Gaussian distribution? All these parameters you can extract using root. Just you can, like the way you can also force to give set parameters, also you can extract, once your fitting is done, you can extract what is the mean of the fitting. And those are very important because you want to extract some physics from out of that. So those parameters are easily you can do using the fitting, histogram fitting of the root. Now this is my basically last feature of the root, which I want to go back because nowadays this is very popular. Like even in our high energy physics data analysis, whatever you have seen, whatever I have done this in this, that you can see there is a signal and there is a background I have fitted, and then I subtracted the background, I got the signal. But in the same kind of, to extract the signal from my data, I can use this artificial intelligence or whatever you say, machine learning technique, neural network technique, and we have a dedicated class for that. It is called Toolkit for Multivariate Data Analysis. So it has, of course, it is dedicated for the high energy physics data, but one can anytime, if you have such similar kind of, you want to do similar kind of analysis, you give your variables or whatever inputs you want to do, you can do it. Of course, it has certain constraint. I don't want to go in that details, but it's a useful for certain kind of data, I would say, not only high energy physics data. And it has a dedicated manual. You can go through this link, and if you are interested in machine learning, you can use this in root. If you are even a little bit, you know about the machine learning technique, you know it basically classifies. It can be binary classification, it can be multi-classification. So in high energy physics, what we do classify two, like one is signal, another is background. So we do binary classification. So you can do like, this is my something you want, which you don't want. So that which you want, that you can mention as a signal, which you don't want, that you can mention as a background. So similar way you can use it in other fields. So there are different machine learning methods which are available here. Some of them I must be, I don't know how much you know, but neural network, you know, nowadays very popular, and multi-dimensional k-nearest neighbor classifier. It is also, there is a separate dedicated machine learning tool for that. And support vector machine is also used in our data analysis. One can use in other data analysis also, not necessary that it has to be high energy physics data. So if just for a machine learning, you know, whatever data you have, it's simulated data, you know, suppose it is a supervised machine learning. So in that case, you have a data set, okay, which first you need to train your certain part of data to train the machine, that how it works, then and a certain part of data you can use it for testing, and then whatever the similar type of any unknown data, you can implement your trained machine to predict it, whether it is a signal or whether it is a background. So those type of classes are already programs or macro, whatever you say, those are available inside this TMVA classifiers. So TMVA classification.c, I have just tabulated here. You can say that it is used, it's an example how to train and how to test using this TMVA classifier. Okay, and it can be multi-classification, so TMVA multi-classification. So it can be multi means not only two, signal, background. It can have different types of classification that you can do. So all these features, I will just at this moment I want to say that using root is also possible to do certain kind of machine learning. Okay, these are the details. I will not go. Maybe when you will do hands-on, if someone is there, you can learn it. So it has you have what just I will summarize here. You have lot of features. In machine learning, we don't call it variables. There are different types of features. And in root, inside this TMVA class, what you can do different correlation between these features. You can study different correlation. So what are the most useful features to separate signal and background? So those kind of study you can do, and all the variables and all the features are once you train, that train data tmva.root kind of one root file will be created, and you can get you can do all kind of study there. Well, you can get basically it will be open to you. So all the study will be done, and you can study. You can do it. You can use it. Okay. So there are actually in 1 hour it is impossible to cover what are the root features. It is not possible. So I will just tell you one of the this RooFit. I think I have once mentioned. This is a dedicated class which can model the fitting and do the statistical analysis. So this plot is showing that RooFit is used, and also root stats. So root stats is another class. I would say it's a framework which whatever you are doing and you want to do some statistical analysis of your data, you want to know the mean, you want to know the RMS value of that, whatever that error correlation function, all this you can do using this root stats. So there are different other, as I have written, it is impossible to cover in 1 hour talk. You go to the root web page and check it. Now, dedicatedly here in the last slide, what I am trying to tell you, application of root other than high energy physics. So one of the well-known field where this root is used, that is the astronomy. So why the astronomy they are using this data? So you try to understand from the basic, what are the features of root? Root is used in high energy physics, huge kind of data is they are producing, you know, in LHC it is a petabytes range of data they are producing, and we are doing the statistical kind of physics, statistical analysis of the data. So if any field, whoever is handling with the huge amount of data and doing statistical kind of analysis, I would say that root is very useful for them, like the way the astronomy people are doing. And nowadays, you know, this also you can use this root for data mining, like database management. Nowadays, you know, you have a huge data nowadays in, let's say in Google, they have a huge data of about the people who are searching different kind of stream, and what they do different types of artificial intelligence to analyze their data, to dig some pattern of their data, you know. So artificial intelligence needs huge amount of data to get some pattern. So whenever this huge amount of data they are handling, so this T-tree which I have explained, so that will be very useful to handle this kind of data. So even, you know, if someone is doing any business, what I am telling, that you need to understand whatever the behavior or demand of the people. So you have to analyze lot of data there if you are really doing modern kind of business. Okay, so there also this T-tree structure will be really useful to handle your data. Like I am giving you in the one example, like nowadays we are suffering for this COVID kind of situation, and we have huge data of COVID patient of there. So sometimes we say, okay, COVID, that means if someone has diabetes or someone has someone is heart patient, so that means that analysis has been done. It's a huge kind of data. So such kind of pattern, still it is available, the data is available. You do such kind of data analysis, it will be very useful if you are using root T-tree structure. Okay, so I would say you can use for, even if you have a small kind of data set, you can use for statistical data analysis purpose, you can use root, but whenever it is a huge amount of data, root is very comfortable to handle that data. So my message to take home message from this usefulness of root for the other fields, I would say, if you are handling large data set, if you need statistical data analysis, without giving any thought, you start using root. That will be very useful for you, and you can do very fast, and it is very efficient tool to do that one. So this another slide I have just kept for this. Nowadays, I have seen many of the students, they know Python, but they don't know C++. So for them, I would say only knowing Python also you can use root. So although root core software is in C++, but there is a Python and C++ bindings. Because of that, even without knowing very much C++ very well, we just knowing Python also, there is a PyRoot available. So you can do your job. You can, without knowing C++ also, you will be able to run this root software. So in this example, I have just I copied from this basically root home page. So this first part is basically it is a piece of code which is written in C++. And this below this piece of code, it is basically for Python. Even I don't know Python. I have just copied it. So both of them can produce this similar. This you can see this left hand side plot. They can both can produce this sin x by sin x into x by x, whatever this plot. So even if you don't know, the message is that even if you don't know C++, if you know Python, which is a very easy programming language, you can go ahead with the root. Now I'm almost done. So this is my last slide. So I have discussed few features, not all, not possible to discuss all features. I have discussed few features of root and tried to make you aware about those features. If you find suitable for your research or your project work, I will encourage you to use those. But before I end, if you want to really explore root, you don't neglect that tutorial directory inside your root installed. Okay, any root install, there will be a tutorial directory. Inside this, if you go, you can see that graph one, T-tree, one directory. And there are example macros are there. You just run it, open those macros, and by yourself you can learn root if you know a little bit of C++. Okay, so I will stop here. So I will encourage you to enjoy this workshop and learn root. Thank you. So I am done, yes. Kavita.
Yes. So thank you, Professor Anki Roy, for giving a very nice and very basic talks. And what I understood, I can explain and I can highlight. You have given us a very good introduction, which maybe the audience is now able to understand what we are going to do in the analysis, in the hands-on sessions. So you highlighted us the vector analysis where we can participate, the density distribution where we can participate in the material science or in any other field, the condensed matter field, or in any other field where this kind of density distribution and their analysis is done. You have also highlighted metrics and uses of metrics using root. And you also highlighted the deep learning using the machine learning. So few students were asking, and I think at the same time you have given the answer. I hope the Naman Mathur is now clear why he was asking that explain the deep learning, machine learning on their use in the brief. So I think you already covered this by saying that where we have to handle the large millions of the events in terms of data in any field, let's say Google data or particle physics or space physics or even in the medical physics in the present scenario of the pandemic, we need to have some fast software, which is, I think, root can be a good platform. So thank you very much, Professor Anki Roy. And also you highlighted a very good point at the end that there is a tutorial directory which always students neglect, and how to start. They ask always, oh ma'am, I have installed, but how to start? So it is very nice point that you make it as a basic talk. You make it as a user-friendly talk, and we will we will be happy to invite you in more and more conferences which we are planning. Okay.
Thank you.
Thank you, ma'am.
Okay, thank you. All of you enjoy the workshop. Okay, bye.
Yes. Thank you.
Bye.
Yes. Okay, so so you all are connected here. So we have already planned some session for you to discuss some brainstorming kind of the session, but I think this is too late. And we have now our internal faculty and we as a coordinators decided that we will keep it as at the end, and tomorrow we will have some installation instruction by the Ritu Agrawal ma'am on GeoGebra and the LaTeX. So please install. We have already sent it to you, the instruction scripts. Please go through it. And many of the students has confirmed that they have successfully installed. We will preferably install root on Ubuntu or virtual Ubuntu in the Windows. But if you have also done on the directly on the Windows machine without installing the virtual Ubuntu, it is fine. You must know which editor you will use. So we have mentioned few editor in our installation scripts. So please go through. And now if you have any question for tomorrow's session or for today's session, please you can discuss now. Otherwise, we will connect tomorrow. The new link will be provided to you, and you have to join with the accepting the invitation. We will not send you the link, but we will send you the invitation through the email. So please register conference, register workshop, and tomorrow onwards we will be inviting you through the email only. Okay. So now if you, I would ask, open the session for questions. For any basic query you have related to the workshop or installation or anything you don't know, you can ask. Or you can type or you can ask, and wherever you are free. Am I clear to everyone? Okay, Sarthak, can you hear me?
Yes, ma'am, I can hear you.
I think then let me ask Kuldeep Lohani. Maybe randomly I can ask. Naman Mathur is here. Yes, Kuldeep, can you say a few words if you have any question or if you have any feedback or any basic questions you have in your mind? Please don't hesitate.
I don't have any. Actually, I am an economist, so I am just exploring the new techniques to
Yes.
use.
Yes, so we will have the brainstorming session at the end of the day. We wanted to keep it today, but we want to understand the audience first. So when while doing the hands-on, we will learn from you how much you are getting learn, and at the end of the day, we will discuss with you by asking one slide on what you are working on and where your field is, so that we can counsel you or provide some training on how you think for your projects. Okay, Lohani, is that clear?
Oh,
yes.
Yes, ma'am. Okay, thank you.
Sarthak, yes.
Two questions are there.
Okay,
Now, one is about the invitation mail for the tomorrow's link.
Okay.
They are asking at what time we will get the invitation mail tomorrow.
Okay, so you will get the invitation email tomorrow morning. Let's say I'll ask Dr. Ritu. She will send you as soon as possible today itself. So don't worry for that. Either today or tomorrow early morning. Is that okay, Fatima? Okay.
Yes,
Okay.
it's okay. Another is from Mihir. Mihir
Yes,
Patel.
I can hear. Yes, GeoGebra downloaded one is same as web one. Yes, Dr. Ritu maybe can. So he is asking, is the same as the web one. Web one meaning the Professor I.K. Rana has given. No. I think GeoGebra you will. If I correct it. I understand it correctly. GeoGebra you will install it as a on the local system. If I'm correct. Okay, so it is still there is a session for you tomorrow to download the GeoGebra and install it. So if you face any problem after even the instruction is given to you, there is a session for you. Yeah, right. And again, the final agenda plus the link will be shared through the Google Classroom only. So please visit the Google Classroom. We will not send the email, but everything will be uploaded in the Google Classroom, and the invitation will be separately given to you from tomorrow onwards or today night. Is that okay,
Mihir? Okay.
Yeah.
Yes. Okay.
Now,
Uh,
for on every day, we will provide them another different link so that they will be more
yes.
comfortable.
Yes, yes. So every time, so we will, don't worry, we will send you today, by today, and everything, the instruction, everything will be on the Google Classroom itself.
Yeah.
Okay, so that every student can see, and you can right away email if you face any issue. Okay, Meher. Okay, Saroj. I think all, please don't hesitate in talking to us. We are here to help
Naman is
you.
asking one thing.
Okay, ma'am, is the origin of software also work same like root? No, no, no. So the origin is very, origin cannot handle the huge amount of data, I must say. Right, so where you have a millions of data, I don't think the origin should work efficiently as like a root.
Origin will not handle this much data.
Yes, the huge
It's
amount
pure.
of data.
Yeah.
Yes, I must say, yes.
And root is a, as much I understood, it is a
Yes.
command-based software.
Command based and script based. You will
Yeah.
learn C++,
And
right?
for the
Yes.
origin, you don't need that thing.
Yes.
It
So,
is
but
simply
yes, but okay. I faced a problem in installing. Let me let me come to solve the Naman issues. Naman, maybe your question, maybe we can also highlight if you let us know in the brainstorming session. What is your field so that we can suggest you better where to use the root. Okay. And now coming back to the Fatima, I have faced a problem in installing of the Ubuntu 20 in the virtual box. Okay, it will be explained tomorrow too. So tomorrow GeoGebra and the LaTeX will be done. The day after tomorrow, we will show you the Ubuntu. So, but Fatima, don't wait for the day after tomorrow. You can share the email by sending the screenshot to us at the kavita.phy@mnit.ac.in, which is given. If you are following the classroom instruction, if you face any problem in the root or Ubuntu virtual, you will please let us know via email. Okay, now is that clear, Fatima? Now coming, I think Fatima is okay. Sartha, I think should we close this session? And I will once again thank you all for making it interacting and very nice session. You will learn more and more when you will attend the hands-on session. Please ask, don't hesitate, right? We are here to help you, that is why. Okay, Bhavik? Okay, so now we are closing this session. Once again, we will also click a photo, maybe at the end of the day by or in between by open your video camera. We will let you know so that everyone will be in that position where we can click, or you can send us some for passport size photograph so we can make a collect. Thank you very much once again, all the participants. So now we are closing and we are leaving this session. Okay, bye bye.